So, good morning, colleagues. Welcome to a special session on intelligence methods for data analysis and computer-aided software engineering. Let me introduce myself. My name is Audrius Lopata, and I will be the chair of this session. So, we have five presentations in this section. So I would like to ask to follow the timer. So we expect that we will use about 15 minutes for each presentation, including questions and answers section. So now we have the first presenter, Laurynas Šniukšta. So the screen is yours, Laurynas.
Thank you. Hello, everyone. I would like to introduce our survey about open source cloud capabilities extension. So from provider and consumer sides, we have consumer interests to execute workloads in the minimum execution time and the lowest price. Of course, they're facing problem that need more resource, and from consumer side, the resource are poorly utilized. Otherwise, they need to have resource on demand, so they have not stable price. And from provider wants to full resource utilization to achieve maximum clients, earn maximum profits, but they must offer on-demand resources selling, so it's also goes to not full resource utilization. So firstly, we need resource management organization. So resource management in clouds include two stages: resource provisioning and scheduling. Resource provisioning is defined to be the stage identify adequate resources for given workloads based on QoS, quality of services. For example, if network packet loss, bit rate, transmission delay, availability, and etc. Where resource scheduling is mapping and execution cloud customer workloads based on selected resource through resource provisioning. So what we can do, we can connect all services into one multi-cloud environment. And we have, while we have diversity of offerings, and let's talk about what offering cloud computer. So we have the providers offering many many free resources, and they searching for a way to find to attract more clients and so on. So we have many free resources or almost free resources where we can collect them and join together to find best solution to even Open Computing Cloud declared that 45% of world service idling. So they offering free running workloads, and they utilize them on idle or sleeping servers. So collect all these and connect to one structure, one multi-environment to create infrastructure as a code for easy managing and quick solutions. So there are open source cloud platforms, OpenStack, offering for OpenStack managing. It consists 6 cores. Nova Compute Instant Lifecycle Management, Neutron, Network Management. In addition, there is more 13 services providing additional functionality at the moment, and each year they making new services. Eucalyptus Private Cloud consists 5 main components: the cloud controller, central management service providing AC2, IPA, and managing all private clouds. Clarus storage component compatible with S3 standards. The cluster controller component acting as the front end of every cluster and managing virtual machines execution and SLAs per cluster. The storage controller, a service management block, volume, storage, and snapshots. The node controller, component managing single hypervisor. OpenNebula on net management, daemon of cluster nodes, virtual networks, virtual machines, user group, and storage databases. Schedule. OpenNebula architecture defined this service as a separate process that can be started independently. Sunstone web interface of OpenNebula. Interoperability of cloud system is very important. So when we're talking about migration functionality, automation of migration, so we need that hypervision layer should match, and the IPA also application programming interface should match. So we analyzed supported IPAs of popular cloud platforms. So here we can see that the Google Compute Engine and Microsoft Azure support only native IPAs, while Apache Cloud Stack, Amazon Web Service, Eucalyptus, OpenStack, and OpenNebula only AC2, others AWS, Amazon Web Service, AC2, and S3 IPAs support. Nimbus also support these both APIs. supported hypervisors. So it's also Apache Cloud Stack supports all kernel virtual machine, XN server, Hyper-V, Elastic Sky X hypervisors, Eucalyptus supports kernel virtual machine and Elastic Sky. OpenStack supports all. vMe Cloud only AS6, and Nimbus also supports XN. Resource scheduling. OpenStack two-step process filtering out of unsuitable supervisors according available source of virtual machine placement, ranking of available hypervisors according available resource of virtual machine placement. Eucalyptus available heuristic, greedy, round robin, power save. OpenNebula two-step process filtering out of unsuitable supervisors according to available resources, ranking according configurable expression. Suitable policy extension method, JSON-based custom filtering, custom and use defined for OpenStack, and for Eucalyptus custom scheduler independent of C language. OpenNebula default schedule can be replaced with a custom independent XML RPG-based interface. So all popular open source cloud platforms independent heuristic approach to resource scheduling support. Basic algorithmic extension for OpenStack, OpenNebula can be hived by configuration to default scheduling subsystem. All platforms can support user-defined scheduling subsystem. OpenNebula support resource scheduling on demand. So virtual machine automate migration task interoperability between different vendor clouds. So need to be same hypervisor, same IPAs, and Cloud Stack and OpenStack are highly flexible and support multiple hypervisors and APIs. Open Cloud Computing Interface standardization is in early stage. There are some initiatives, but it's only in early stage, and it must include APIs protocols for many kinds of cloud management tasks, including deployment, automatic scaling, monitoring, and much more. But major public cloud services providers, Amazon Web Service, Google Cloud Platform, and Microsoft Azure, don't support unification standards, and they keep working on own API. So it's not pushing for standardization. Thank you. These questions.
Okay, thank you very much. Do we have any questions from on-site participants? No? Great. So I have one question. So in general, you performed kind of analysis of cloud-based services and solutions. And is your proposal oriented to large enterprises or smaller and medium enterprises?
Actually, it can be deployed on this and also it can be for small. We can make it. It can be hybrid. We can use actually anywhere, and this
Okay.
can be.
And one more question. How do these companies should choose the most suitable infrastructure-related solution? What should be the main steps of these companies they should perform?
Excuse me, in the beginning.
How do these companies should choose the most suitable infrastructure-related solution according to your proposal? And what should be the main steps these companies should perform?
So of course it's this helping execute utilization for providers. So they offering good prices. This survey also helps to choose to find some solution, but actually it need to be done also survey what are prices, what are services offered now, and by that, what services is needed should be done each time, like a survey. And
but it is difficult to predict because the prices can be changed after, for example, 1 month or 1 year.
Yes, that's why automated migration is also here, and if something goes, the prices like you told, the prices are changing or something, you can you are on an open cloud and you can migrate quickly to different, and even on a live migration. So you can do this.
Okay. So I see that we do not have more questions. So thank you very much. Thank you for presenter. And now we'll have the next presentation. So okay. Let's start the next presentation. We don't hear you. We don't hear you. We still don't hear you. No voice. No, still no voice.
Sir, am I audible now?
Yes. Now we hear you perfectly.
There was some issue with the mic, sir. Sir, may I start my presentation?
Okay.
Sir, please allow me to share my screen. Some other participant is currently sharing. That's why.
You should have this possibility right now.
Okay. Sir, is my screen visible now?
Yes.
Okay. Bismillahirrahmanirrahim. My name is Yaver Rashid, and I have recently completed my master's degree from Department of Computer and Software Engineering, National University of Sciences and Technology, Pakistan. The research has been supervised by Professor Dr. Muhammad Abbas. Indeed, it is a matter of great honor to present my research to such worthy gathering of scholars. The research article which I have to present today is a novel model-driven framework for image enhancement and object recognition. Sequence which I would be following is as flashed on the screen. First of all, introduction, background, and problem area. Digital image processing is the processing of digital images with the help of digital computers. Broadly, it encompasses low-level, mid-level, and high-level processing tasks. Image enhancement and object recognition are interesting areas of digital image processing. Due to the poor contrast and noise in most of the real-life images obtained from various systems that are satellite imagery, medical imagery, biometrics, surveillance and security, etc. Image enhancement primarily deals with improving the quality and bringing out obscure details for human perception as well as for automated processing of specific computer-based applications. Over a period of time, various spatial and frequency domain techniques of image enhancement have evolved. Object recognition, on the other hand, deals with recognizing objects and making sense of the recognized objects and is generally preceded by some image enhancement tasks. Accuracy of object recognition algorithms and classifiers have also improved tremendously. With the increasing sophistication of image enhancement and object recognition in digital image processing, the complexity of development of corresponding systems involving image processing tasks have also increased. Model-driven software engineering is considered as a major breakthrough in providing better visualization of complex systems and reducing complexity of software development. Models and transformations are considered as primary artifacts and major corporate assets for automation and software development. Models are created at higher abstraction levels. Various domains have benefited from this powerful abstraction-based approach. Image processing is an integral part of modern systems like industrial automation, medical surveillance, and security. Whereas modern technological trends require prompt development of software systems. The development complexity of such systems is frequently managed through model-driven architecture. However, for image processing operations like image enhancement and object recognition, the low-level implementations are performed separately during system development. This severely delays the system development and testing, as few components of the system are developed through model-driven architecture, and image processing operations are implemented in isolation. Coming over to the literature review, salient points of literature review are: databases of IEEE, ACM, and Springer are searched for the relevant conference and journal research articles. We have cited 20 references, which are both conference papers and journals. In summary, the reviewed literature reveals the necessity of image enhancement and object recognition tasks for various domains. The reviewed literature also highlighted the importance of model-driven software engineering in reducing complexity of software development. Most of the reviewed literature focuses on the concepts of digital image processing and model-driven software engineering distantly, and very little integration of the two domains have been noticed. Now I'll discuss the identified research gap. Although there exist few studies that have been duly cited in research article where image processing is explored in the context of model-driven software engineering, however, these solutions have very limited scope as well as limited domain-level concepts. Moreover, they cannot be applied and integrated in MDA development flow for larger systems. Consequently, the state-of-art MDA approach to effectively support the image processing operations like image enhancement and object recognition is hard to find in literature. Therefore, there is need of a comprehensive model-driven architecture-based approach to perform critical image processing operations with simplicity. Furthermore, such operations should allow the seamless integration with other MDA-based system development approaches or frameworks for the execution of image processing tasks. This article introduces a novel framework which we named as MIORF, that stands for Model-Driven Image Enhancement and Object Recognition Framework. Particularly, a meta model or a domain-specific language is proposed that allows modeling and visualization of complex image processing and object recognition tasks. Subsequently, an open source customized tree editor developed using Eclipse modeling framework and Cirrus-based graphical modeling tool or workbench have been developed. Both are distributable via Eclipse-based plugin. Consequently, the proposed framework allows modeling and graphical visualization of major image processing operations. Moreover, it provides strong grounds for model transformation operations, for example, model to text transformations using Axelio language for generating executable MATLAB code. Furthermore, it systematically combines model-driven architecture and image processing concepts, which are detailed enough to be easily integrated into a wide variety of systems. Before explaining the framework and its artifacts for comprehension of the audience, I want to explain that what the user will actually get from this framework and its supporting tools. Basically, a graphical modeling tool will be available to the user, which will have a drag-drop palette from where a concept can be drag-dropped to the diagram area. In this manner, user will be able to make complex models of image processing scenarios, like we can see a model developed using our tool related to medical imagery domain. This model is abstractly showing various image processing steps involved in the enhancement of X-ray image. Coming over to the proposed methodology, as an initial step, a comprehensive review of the selected literature has been undertaken to bring out detailed concepts pertaining to the relevant domains. Thereafter, a meta model or DSL has been defined. As part of implementation, tool support is provided, which can model and visualize the image processing scenarios. For validation, as a case study, image enhancement scenario of a medical X-ray has been modeled using our tree editor and graphical tool. The future perspective includes generation of executable MATLAB code as a low-level implementation via model-to-text transformation using Axelio language. Now I'll present the proposed framework. First of all, the meta model. The meta model consists of one main and two sub-packages. IEOR-S is the root concept, which contains most of the concept of our meta model like image and dataset, etc. Spatial image enhancement package contains concepts pertaining to the image enhancement in spatial domain. IES is the root concept that contains the abstract concept of preprocessing. Preprocessing is further specialized into point processing, histogram processing, arithmetic operations, and filtering. They have their own specialized hierarchies. Another sub-package of our meta model is the object recognition package. It contains concepts pertaining to the feature-based object recognition. ORS is the root concept that composes various concepts pertaining to object recognition. Possible integration of our system with various systems like medical imagery system and surveillance and security system has also been abstractly defined in our meta model. Coming over to the implementation portion, the meta model has been implemented in the form of two editors. One is the tree editor and the other is graphical modeling tool. Both these tools allows M1 level modeling that conforms to a meta model at M2 level. We can see on the slide that the tree editor allows instantiation of various concepts of meta model. We can model any image processing scenario in tree form using this tree editor. This is our graphical modeling tool. It provides better visualization of the model scenario. It has a drag drop palette and the modeling area. We can instantiate various concepts of meta model by drag drop from the palette into the diagram area. Various attributes and associations among instances can also be set in a user-friendly manner. Coming over to the validation portion, we have taken a case study from the famous digital image processing book written by Gonzalez et al. Various image enhancement techniques are often used in combination to one another to highlight the features of interest. The image on the right side of the slide shows nuclear whole body bone scan, which is used to diagnose tumors and infections in bones. As noticed, due to the high noise content and narrow dynamic range of gray levels, it is not possible for the medical staff to read the relevant details. Our aim is to use various image enhancement techniques for sharpening it so that skeleton details can be brought out from the image for effective diagnosis. This technique involves the techniques involved in various steps are as shown on the screen, like taking Laplacian of the image, doing image addition, and applying Sobel filter and power law transformations to sharpen the image. The enhanced and much sharper image applying these techniques is shown on the screen. Now we see that how our tool models this specific image processing scenario. This is how the scenario has been modeled using our graphical modeling tool. This is the notation of the original image. These are the various techniques which are applied. And this is the final image that has been obtained. From the model, we can get fair graphical visualization of the case study image processing scenario. Coming over to the discussion and limitation portion. This research is a significant milestone as a comprehensive and open source model-driven framework for image processing operations is hard to find in literature. There exist few well-known image processing solutions like Simulink image processing toolbox and Eclipse image N. In contrast to Simulink Toolbox, MUOF deals with the pure platform-independent models that can be transformed to different target platforms as per requirements, while Simulink Toolbox is only effective in given environment. Furthermore, Simulink Toolbox is proprietary, while MUOF is freely available. On the other hand, ImageN and MUOF share certain common features, like both are based on object-oriented approach and freely available. However, MUOF operates at higher abstraction level, while ImageN performs image processing tasks in Java language at lower abstraction level. Therefore, MUOF is more effective in terms of usability. Another significance of MIOF with respect to Simulink Toolbox and ImageN is that it is highly interoperable and can be employed and integrated with other MDA frameworks. For example, meta model of MIOF can be integrated easily with other MDA frameworks or MDA-based systems for the execution of image processing tasks. True essence of this framework is its core extensible capability. Meta model has been made modular and flexible as it has been defined according to the principles of separation of concerns. This achieves the sole purpose of high cohesion and low coupling. Framework has the capability to absorb new concepts efficiently and seamlessly. Moreover, it is flexible enough to be easily integrated within the existing MDA frameworks. MIOF support both model-to-model and text transformations. Particularly, the meta model of MIOF may serve as a source meta model to perform model-to-model transformation in Atlas transformation language. On the other hand, model-to-text transformations can be implemented in Exilio language using the concepts of MIOF meta model to transform M1 level models into low-level implementations like MATLAB code. As a tool support, a tree editor and graphical modeling tool have been developed, which are distributable via Eclipse-based plugin. Some of the limitations of this research are that currently MIOF supports basic image processing tasks like image enhancement in spatial domain and feature-based object recognition, while advanced techniques like frequency domain enhancements and correlation and CNN-based object recognition are not supported. Similarly, no transformations have currently been written for MIOF to generate target low-level implementations. The proposed future work. In future, we intend to extend the proposed framework for incorporating concepts related to image enhancement in frequency domain and object recognition using correlation filters and convolutional neural network, and enhance our tree editor and Cyrus tool as well. Similarly, writing Exilio transformation code in order to transform system models developed using our tool into executable MATLAB code is also a milestone to be achieved. This brings me to the conclusion of my presentation. Thank you all for patience hearing.
Okay, thank you very much. And we have one question from on-site participant, Professor Vytenis Kunis.
Sir, please.
Hello. Well, thank you very much for very nice presentation. When you were talking about models for image processing, for medical image processing, I have a particular question. Did you consider that medical images usually are in the DICOM format, which implies so-called DICOM model of real world and has a lot of information in the image headers based on that? So can you implement, can you transform and import that data and use for it? And the second part of the question is, did you investigate other application areas for similar models?
Sir, sorry, I couldn't get your first part of the question. The question which I got, what I understand, you want to ask that can an image or information can be imported? You asked this question?
No, I mean the medical images are based on a DICOM model of real world. So they imply already some special kind of a model, which is domain specific for medical images.
Sir, basically, we can basically this my model, my approach takes any image which can be X-ray image, which can be real life image, or which can be any image, satellite image, and then we can then it applies modeling of various techniques like taking various filters, Laplacian image negatives in order to sharpen it. Basically, application of various techniques on image and then generate target low-level implementations, for example, generating of MATLAB code, so that an image scenario is modeled using our model and then transformed automatically into low-level implementation so that a running system is obtained. This is basically what the purpose of this research is. So we can take, sir, any image, a visual image, it should be a visual image, and then we can apply various techniques on it, sir.
Thank you very much.
And sir, it can be used for various domains. Like in my master's work, I have used it for the surveillance and security domain, and actually generated the target low-level implementations. I have proposed a full-fledged surveillance and security system which allows modeling and then generate target low-level implementations.
Okay, thank you very much.
It can be used for a variety of domains, sir.
Okay, thank you very much. We do not have more questions. Thank you for presenter. Thanks.
Sir, thank you, sir.
Okay, and our next presentation, we have on-site presentation, and the next presenter is Ilona Veitaitė. Čia yra problema. Padarom viską.
Okay.
Tada čia padarom ir tada sėkmės.
So, hello everyone. My name is Ilona Veitaitė. I'm from Vilnius University. I will present our paper knowledge-based generation of the UML dynamic models from the enterprise model illustrated by the ticket buying process example. And this paper is prepared by me and my supervisor Audrius Lopata from Kaunas University of Technology. And let's begin. So firstly, I will present you the outline, so it will be introduction, then the enterprise model, basically the background of our research, our background information, then I will present the example, and of course the conclusions. So, introduction. Nowadays, information system engineering process is quite challenging for all types of information system professionals. So in process of designing, in process of modeling, in process of requirements gathering. So these processes are quite difficult and challenging, and enterprise modeling basically is the ground phase of information systems development life cycle. Basically is one of the most important one, because all the modeling part is done during this phase, and the right choice of particular enterprise model may impact full process of information system life cycle stages. So enterprise models applications are adapted in various ways, and different types of models are created. Sometimes there is used the natural language, sometimes it is used other patterns, other frameworks. I would like to present our particular enterprise model, which we used in our research, and how it relates with UML, Unified Modeling Language Models. So at first, as you all know, UML is a highly recognized and understood platform for information system developers. It is basically the standard notation among professionals, and it is understandable as for the professionals of IT sphere, and also it is easy to present information systems goals, process of development for the business users, for the business professionals, that they could visually understand the future application results, future results of created information systems. And of course, UML models can help in generating code from the design and apply the design patterns and help to the process of information system development. So basically, the most important thing that all UML models which are created during the design process would be correct, would be verified and validated, and have enough quality, so it would be easier for the programmers in the further phases of information system development part. Our challenge, our idea is to present the usage of particular enterprise model, which is basically used as a storage of full information of problem domain field. And basically this knowledge which is stored in enterprise model is already checked, already validated and verified by the analysts. So it may be said that all knowledge which is already stored in enterprise model is basically enough for the creation of UML models, and we are doing it through the transformation algorithms. That's why we can say that basically the knowledge which is stored in enterprise model is enough for the creation of UML models from different types of UML models, basically all types of UML models, as it would be structural or behavioral, can be generated from enterprise model, but we focus more on the dynamic part, dynamic models. Today I will present the idea of enterprise model, which was basically presented almost 2 decades ago, and our research goal is to present the possibility that this particular enterprise meta model and enterprise model is enough to use as a background for the all UML diagrams, UML model generation process. And this will be illustrated by the example of ticket buying process, because basically, as you know, UML diagrams, UML models are dedicated for the presenting information system in different views, in different perspectives. So that's why we use one example, and we will show the different types of UML diagrams which can be generated from enterprise model and basically are related with the particular ticket buying example. So firstly, enterprise model. It is our background, it is our knowledge of the problem domain storage, and basically enterprise meta model is formally defined enterprise model structure. As I said, it was presented almost 2 decades ago, but our main goal is to adapt and to use it into UML UML model generation process. Basically, an enterprise model is the model where all the problem domain knowledge is stored, and according our research, according the previous researches, we can say that if the knowledge stored in the enterprise model, so basically it is already checked, already verified and validated, and it is enough for the UML models generation. And it is enough main source of all necessary knowledge which should be used in the generation process of UML models. So talking about the enterprise model in details, we can see that this model consists from quite a long list of the elements, such as events, objectives, processes, functions. We also have an actor. Actor can be related with the particular processes, with the particular functions. Also, process is related with the material flow, and in this case, in this model, the material is divided into input flow and output flow. So we can define these flows. Also, we have information flow, talking about process input-output attributes and information processing input-output attributes. And also important elements such as information activity and business rules, which basically helps to show to use the elements and relationships within these elements, because the business rules defines how these elements are related according the rules, according the problem domain field, and it is basically enough to use in the generation process. And if you want to get this information from the UML, from the enterprise model for UML diagrams, UML models generation, we use transformation algorithm. So firstly, we have the top-level algorithm with a list of these steps. At first, we need to identify a model, or UML model, which we are trying, we will start to generate. After choosing the particular model, we identify the initial element, the beginning of this generation process. Then we generate this initial element, and we are searching, we are selecting and then generating next related element which relates with the initial element, and after that we get information from enterprise model, the link between these two elements, and according business rule we relate these two elements, and then we will starting our algorithm from the beginning. Then we are searching for other elements which are related with the initial and the next element after the initial one, defining their links and defining the rules according which they are related. So basically I presented these steps, and here is the algorithm. I would like to say that for each separate UML model generation part, we have separate algorithm, and each element each model is generated according the more detailed transformation algorithm. So what will be used in our particular example? So basically in this research, most important elements which are stored in an enterprise model is actor element. Basically it may be the person, maybe user, maybe subject, subsystem, or some module, or etc. Also process and function elements are necessary for the further process. Information flow, how these elements are related, and business rules, which defines how these elements, according what rules, are related. And now the example. So basically we have a simple example of ticket buying process, and it may seem very simple and very easy, but if we try to analyze this example from different perspectives in information system design phase, so for the programmers or designers, all the diagrams should be very detailed, and these models which are created according the knowledge used in enterprise modeling and designing phase are very important, and if it would be done only with the help with the analyst without any enterprise model and knowledge storage, it would take a lot of time and efforts, and of course it may be done some errors which will bring problems in the further information system development process. So basically the main idea that, as I already mentioned, enterprise model is our main source, main storage of knowledge needed to the necessary for the creation of UML diagrams. So we think, and as we are using our enterprise model as our main source, so all the information already stored in this enterprise model is verified and validated, and basically it is correct for the generation of particular models. So I'm continuing with the example. So if we are talking about UML use case model, and if we want to generate it from enterprise model, so we will need 4 elements from enterprise model. So it will be actor, process, function, and business rule. In use case model of UML, there will be 3 elements such as actor, use case, and relationship as include. And in ticket buying example process, we can define 3 types of the actors: client, manager, ticket system, some list of use cases, so inquiring ticket availability, filling form, booking ticket, paying ticket price, printing form, refunding payment, and cancel the ticket. And we will have 6 includes. 6 include connections which are defined by business rules stored in enterprise model. And after the transformation algorithm, particularly dedicated for use case model, we will receive the result use case model of ticket buying process with all the elements of the actor, with use cases, and include elements which are defined by the business rules. Another model of the same example is sequence model. So from enterprise model, we will take the same elements such as actor, process, function, business rules. But in this case, in sequence diagram, we will use sequence model elements such as lifeline, message, and execution specification. And you also see the list of ticket buying example. So there are already also 3 types of the actors or lifelines in sequence model case, the list of messages which are related with this example, and 10 execution specifications. After the transformation algorithm of UML sequence model, we will get the model generated from enterprise model according to all the rules and requirements. Then we will have a state model, UML state model, where we have taking information from enterprise modules such as process, function, and information flows. And in UML state model, we will have 2 types, so behavioral state machine element and composite state. And in ticket buying example, we also have some elements which are related directly to the example. After the generation process, we will have the diagram generated as you see in the example. And the 4th diagram of the UML dynamic part is the activity model. So also we will take the elements from enterprise model such as actor, function, process, and business rules. In UML activity model, we will have partition activity control nodes. And from this perspective, we will use in ticket buying example the actors such as partition element, UML activity model element, client, activities, and we will have control nodes which basically are defined by business rules and enterprise model. So there will be initial node to activity, final node, decision node, and we will have the result of the UML activity model generated from enterprise model. So in this example, I represented 4 diagrams of dynamic part of UML diagrams, which are generated from enterprise model, and basically it shows that knowledge stored in enterprise model basically is enough for the generation process. And conclusions, so in the first part, I presented you the enterprise model as our main source of the knowledge. Also, I presented top-level algorithm, transformation algorithm for the generation process, described step by step, and also presented how we are using, which elements we are using in this particular research to show the possibility of generation process. Particular example shows and illustrates how we are doing this process of generation, and what types of UML models can be generated. As I said previously, we are focusing more to the dynamic part of the UML models, but it still confirms that also the static diagrams of UML also may be generated from the enterprise model. And for examples of dynamic UML models generated from enterprise model shows and confirms the main idea that enterprise model as a storage for the information system development process in the design phase is enough for the UML models generation process. So basically that's it. Thank you very much. Sorry for the more time I took. than expected.
Okay, so of course, as a supervisor, I'm very interested in the results of this research. And could you please explain what kind of additional value your proposed method will bring to IT companies, and why they should apply it in their practice?
The main idea is that, as I mentioned in the beginning, that the process of the enterprise modeling, the preparing of design phase, project models preparing is quite difficult process. And if the analysts are doing it relating only on their experience without using any other models or techniques, the process may take more time than it is expected, and as the it may be some human errors or some errors in the process which can make the process of ES development take more time and dedicate this time for correcting errors. And if we are using enterprise model as our storage where the information is already verified and validated, so the process should be, basically it will be done faster or according the plan, and it will be avoided the more number of errors, the corrections part, and the process will take time as it was planned without any additional interruptions.
And how they can calculate how much time they saved using this method?
Of course, the main idea, if you talk about the time, we can compare the average time of the information system design phase when project models are done based on the analyst experience, and of course if we are comparing it with the automated generation process where the models are generated automatically, which also are automated in correct way without errors, so it will be less time and we can count that, but in the future works.
Okay, thank you very much.
Thank you.
One more question, please, Yavan.
Okay, I want to ask that, have you written any transformation rules, like model-to-model transformation rules for transforming the enterprise models into UML models and generate UL model from the enterprise models? Have you written any transformation rules, and what language or what language you used? Is it Atlas transformation language or any other language you used?
In previous researches, we analyzed the separate UML models, so we prepared transformation algorithm basically for each model of UML language, and in this case we illustrated with separate examples the generation process according the particular transformation algorithm for each type, almost for each type of UML dynamic language.
I want to ask that, have you written your own transformation algorithms, or you are using already made transformation rules or algorithms? There is a method of writing transformation rules. If you want to generate a model from another model, so you have to write a model-to-model transformation, which are called model-to-model transformation rules. So I want to ask, have you written your own transformation rules, or you are using someone transformation rule and generating the target models, target UML models?
As we are using our enterprise model as our source for the generating process, and we adapting it for the UML model generation, so we try to create our own transformation algorithms from top level to the particular UML model generation part.
Okay, can you name the language in which you have written those transformation rules?
We didn't add any rules at this moment. We created only algorithms, and we are defining this, and we prepare it in the future works.
Okay, that is the future perspective. You will write the rules in future. Okay, thanks a lot.
Thank you.
Okay, thank you very much for presenter. And Now we'll have next presentation, standardized questionnaires in usability evaluation, applying standardized usability questionnaires in digital products evaluation. Okay, please.
Hello, everyone. I'm going to share my screen now. Okay, my name is Oana Rotaru, and I'm going to present standardized questionnaires in usability evaluation, applying standardized usability questionnaires in digital products evaluation. This is my first research paper since I'm a PhD student at Polytechnica University of Timișoara. First, I'm going to start with some theoretical background. So the usability evaluation, has a great impact in the human-computer interaction. It's one of the basic elements used to verify the quality of any user interface. The actual definition is much larger than that. The usability is based on the assumption that users are rational agents interacting with the system and being capable to use their knowledge to receive information from the system's reactions. There are plenty of usability evaluation methods. One of the most popular applied methods is the user observation. But in our paper, I will refer more on another popular method, such as the questionnaire method. People often think that a high level of usability is accomplished literally only by adding a simple and clear interface, but usability is much deeper, and the clear information which is displayed to the user has a great impact on the usability level too. So in order to improve or standardize this usability testing process, there were developed some targeted questionnaires based on the essential components of the usability. The five essential components of the usability are the learnability, efficiency, memorability, the error rate, and the user satisfaction. I'm gonna detail now four of the most well-known standardized questionnaires. They are here, and in the next slide, I'm gonna detail them. So the first one is the software usability measurement inventory. It's a 50-item survey, and it's especially used for evaluations such as product against product comparisons or product against some standardized database comparisons. Also, this kind of questionnaire is not free. You have to pay for using their database and their information. Another questionnaire, another standardized questionnaire, is the system usability scale, is the most frequently used one. It consists of 10 statement questionnaire, half worded positively, half negatively, and it requires the users to rate their perception of agreement or disagreement to those 10 statements. And I forgot to mention that it's a free questionnaire. Another questionnaire is the post-study system usability questionnaire. It has 16 statements which can be customized. It's frequently used for evaluating websites or different software interfaces or products at the end of the study. One of its advantages is its replicability. And the last one presented here is the questionnaire for user interaction satisfaction. It measures the user's subjective satisfactions with any computer interface, and it's commonly used in commerce, industry, international education, and so on. Our applied case study in this field, we had 5 teams of master degree students participating at the interactivity and usability classes of Polytechnica University of Timișoara. The 5 teams of students had to compare all these 4 types of questionnaires, and also they had to analyze which one is the most suitable for their own project to be evaluated. The first project assigned to the first team involved in this research is the Spotlight Heritage Timișoara project as a mobile application. This is a cultural project developed by the Polytechnic University of Timișoara in a partnership with National Museum of Banat. And it's an AR applications containing several stories about the city that highlights neighborhoods and communities of the city of Timișoara. The students chose the system usability scale questionnaire, and they mentioned that the reason for their choice is because it's fast and easy to use by the participants, and they also chose it for its rationale of the score calculation. Here we have, they also have had to customize their choice. So this is the customized version of the system usability scale questionnaire for the Spotlight Heritage Timișoara mobile application. And also here on the right side of the slide, I have a small screenshot from the Spotlight Heritage mobile application. Okay. The second project is the Open Virtual Mobility Learning Hub project, also as a mobile application. This is an innovative multilingual environment, was created as a part of the project Open Virtual Mobility. And its purpose is to promote the collaboration between universities, collaborative learning, and the main content of the mobile application is the open educational resources. The choice of the students was the use of the post-study system usability questionnaire. The reasons for their choice, it's especially, and the fact that the PSS-UQ is more complex than SUS, and it would be more helpful to find more precise results, and also because it's free. Here I also have the customized PSS-UQ questionnaire proposed by this team, and on the right side of the screen I have a little screenshot of the Open Virtual Mobility Learning Hub mobile application. The third project is the e-learning center website project. The students chose the SUS questionnaire, and the reasons are because this kind of questionnaire is suitable for websites usability evaluation. So the major changes of the question would be useless as long as it already questionnaire from other studies. Here I also have the screenshot of the e-learning center website and the customized questionnaire by our students. The fourth project is the Unicampus website project. Unicampus is an initiative of the e-learning center of the Polytechnic University of Timișoara, and its main purpose is to create and develop the first MOOC, Massive Open Online Course in Romania, being an online virtual platform for free courses and also available to anyone. Here is a screenshot from the Unicampus website containing already some implemented courses on it. The students chose also the SUS questionnaire, and the reason it's because it's a short questionnaire and it's easier to be filled by the participants. This is the customized questionnaire of the SUS based on the Unicampus website project, and we can observe that it's it's focused on the major directions to find the usability evaluation problems. The last one, and also the fifth one project, is the Virtual Museum of Polytechnica University of Timișoara project. It's a virtual reality application developed for the Technical Museum of Polytechnica University of Timișoara. The application is in fact a journey through the history of the university, such as seen as a virtual museum, and also this application is not entirely developed yet. It's not a final product. Also, I have here a small screenshot from the virtual museum of university, from Polytechnica University of Timișoara. The choice of the students was the post-study system usability questionnaire, and the reasons for the choice is its replicability and the fact that it could cover more other possible scenarios than the SUS questionnaire regarding their own project, the virtual museum, virtual reality application. As conclusions, we observed that 3 out of our 5 teams tend to choose the SUS questionnaires rather than PSSUQ. So we have 60% rate of using the SUS and the 40% predilection of using the PSSUQ. We kind of could have been able to predict that the students will choose these 2 questionnaires rather than other 2 questionnaires, because these 2 are free. You don't have to pay for them. And also, we observed that both of the teams which chose the PSSUQ had to test the virtual reality application and the mobile application for the Open Virtual Mobility Learning Hub project. So these products require more specific research for the possible usability problems than the websites, for example. Also, comparing the options of the teams, we can conclude that choosing one of the standardized questionnaires depends also on the complexity of any product or the stage of development. So there was an interesting conclusion coming from the students that a long survey can overwhelm the participants and induce, I don't know, thoughtless answers or boredom maybe. And as a future work, the students had already applied the questionnaires in their projects at the interactivity and usability subject as master degree students, but we intend to encourage more future generations to analyze these questionnaires and to analyze the impact of the chosen questionnaires over the project assigned to them. Thank you very much.
Okay, thank you very much for presentation, and I would like to ask one question. So about the practical implementation of your research, and perhaps it would be a good idea to suggest kind of decision support system in order to choose the most suitable questionnaire or something similar. Could you please comment?
It would be. Yes, it would be. It may be a future work for us. But this was my first research paper in this direction, and I'm gonna do more.
Okay, thank you. More questions? Oh, we have one question from on site from Kaunas. Nesigirdi per tą mikrofoną.
Hello, thank you for interesting presentation. I would like to ask practical question. How many students participated in every group of your research? You mentioned that it was 5 groups. And as I know, the SUS scale is used quite often, about 43 research studies are using especially this. So you just showed that this information it's clear, and this information is right. So I would like to know the number in every group, because there are some recommendations that in the research when we use this to involve about 15 students. Thank you.
Okay. We had some around 10 in every team, around 10 participants in every team, and they also just proposed some versions of the questionnaires, and afterwards they applied it.
Okay, thank you very much. Thank you
Thank
for
you also.
presenter. Thank you. And now we're waiting for next presenter, and the last presenter of our section on this part of our section, and the presenter, as I understand, will be Vytautas Volungevičius, yes?
Yes, of course.
Okay, so go on.
Okay. Good afternoon. My name is Vytautas Volungevičius. I am one of the co-authors of the paper on research of semi-automated database development using data model patterns. The other co-author is Rita Butkienė. Nowadays, more and more businesses move online. As most businesses need some kind of data, they also need a place to store that data. One of such places is a database, but the development of a database is tedious and sometimes repetitive work. So today I'm gonna present one way how you can semi-automate database development. Using this method, we managed to cut our test database model creation time in half. The presentation that I prepared today can be divided into two sections. The first one, in which I will briefly talk about the reasoning behind this research, and the second one, in which I'm gonna talk about the case tool, a digitalized data model patterns library, and the experiment which results show that this method of database development has merit. I should also mention upfront that the research focuses on the relational databases. Most processes can be divided into steps. Database development process isn't an exception. Graham Simpson provided a detailed process with every single step that needs to be taken into account while developing a database, but the core steps in a database development process is a creation of a conceptual data model, which we can get from the requirements and interaction with the universe of this course. From the conceptual data model, we can create a logical database schema, and from the logical schema, we can create a database. As the database development process is similar to a waterfall model, this means that the key to success is a precise and correct conceptual data model. But it's not that simple to create a correct conceptual data model. Many designers faces at least few problems. The first problem that we might identify is a semantical mismatch, as the same word can have multiple meanings. Secondly, not everything that exists in the universe of discourse can be transferred to a model, and certainly not everything should. Furthermore, to develop a correct conceptual data model, one must be familiar with the domain area, and many novice and even expert designers struggle when it comes to finding entities that are necessary for a model to be complete and was not mentioned in the requirements, as the client might think that they go without saying. It's not a new concept to automate database development. There already exist at least 4 methods that could be used to automate relational database development. All these methods, linguistic-based, case-based, ontology, and pattern-based approaches, were analyzed in the paper. In this presentation, I'm not going to expand much on them. I'm just going to say that the pattern-based approach had the most advantages, and the current technologies allow us to implement it and use it in the database creation. I guess 99% of the people here already knows what a data model pattern is, but maybe there is one other besides me that needs a reminder. So a data model pattern is a set of entities and relationships between them to solve a particular recurring problem. Most designers already use patterns without even knowing. Some of the designers already are familiar with the concept of data model pattern and the existing patterns. Some chooses to use them, some don't. Data model patterns can have different abstraction levels, which might discourage designers to use them. And most of the data model patterns are in a textual format. That's why their conscious usage is low, as you would need to open a book and look for it. So the current problem is that there are no convenient way of using patterns, as now you still have to redraw them by hand even if you know them. That's why there is a need for a digitalized data model patterns library and an interface to use it. As I stated before, patterns can be used to semi-automate database development, but for us to be able to use data model patterns in such way that they could semi-automate database development, we need a tool. The purpose is to create a tool which could simply let the user pick a pattern or a set of entities from a pattern and copy them into a data model that is being created, which would allow us to jumpstart a conceptual data model development. So the set tool consists of two parts. The first is a digital data model patterns library. While creating this library, a few key decisions was made, as different patterns might contain same entities, and we do want to be able to connect different patterns using the same entities. The decision was made to use a single object of the same entity in the entire library. Secondly, as there are different abstraction levels of patterns and even of the same entities, the decision was made to only add the core attributes of the entity from all the different patterns it was used in. The reasoning behind this is that attributes almost always are specific to business data that is needed to be stored, and it would be easier to add them by hand from the requirements than add all possible attributes from the patterns and then delete the unnecessary ones. So basically, the data model patterns library was created in the Magic Draw, and the plugin developed for Magic Draw as well. The plugin have three main functions. It is a search, copy selected, and find related. Using these three functions, we can identify two new use cases for conceptual data model development. Using the keywords from the requirements and the search function of a case tool, we can find all entities and copy them into a new conceptual data model. And using a find related elements function, you can search for related elements that might be useful in a conceptual data model that is being created. In a scientific community, we always need proofs. So to prove the validity of a case tool and a chosen semi-automation method, an experiment was conducted. An idea of an experiment was simple. We just wanted to measure the coverage of the original model using patterns and the time aspect needed to develop the same model using different methods. So the first step of the experiment was to find an open source large to medium database model. As there are not many large open source databases, we chose Microsoft AdventureWorks database, as it was complex enough to show the possibilities that usage of patterns brings. Secondly, we needed to set the coverage criteria that should be measured. And for the criteria, we chose the coverage of entities, attributes, and relationships, as well as the time difference required to draw them. Once the experiment was finished and all the measures were calculated, the results were as follows. So for the coverage of entities that have the same name in patterns and in the chosen test database were only 14%. As we would expect, it's because the pattern entities have more generic names, and while developing concrete model, we choose to name entities appropriate to the domain area. the coverage of entities with the same name but that are differing in forms in a data model patterns and in a test model were 76%, which this coverage percentage also support John Giles' statement that using patterns we can cover up to 75% of any database. The coverage of attributes were 47%, as mentioned before. While preparing the digitalized pattern library, we chose to use only a core attributes of the entities. And the last criteria, the coverage of relationships, were 58%. One of the reasons why the coverage of the relationships was lower than entities is because not all the entities were covered. And of course, I guess the most important measure is time, which reduced from 75.5 minutes to 29 minutes. In conclusion, in this research, we managed to propose and create a tool for a pattern-based approach and tested its validity. The overall result proved that pattern-based approach has merit, and I believe that expanding the data model patterns library and improving the case tool could yield even better results. Some might argue that patterns are too abstract and directly using them, we lose some readability of the model, but using a case tool which allows a user to copy pattern entities and modify them solves this problem that direct pattern usage might cause. I would also like to acknowledge that all the patterns were based on David C. Hay and Len Silverstone proposed patterns. And thank you for your attention.
Okay, thank you, and thank you for presentation. And I have one question. I would like to know, is your method oriented to platform independent or platform specific solutions?
Could you rephrase that?
For example, is it suitable, it's another part, but is it suitable for relational databases only or for object-oriented databases as well?
I would say that it's suitable for relational databases, as I stated before in this presentation, I think in the second slide.
Mm-hmm.
And that's it, I guess.
Okay. And about the platform independent or platform specific, so I mean that, for example, is it your method is specific, for example, for Oracle database specific or MySQL database specific, or
no.
It is platform in general independent?
I would say that it's platform independent because if we create a model in a Magic Draw environment, we can then transform this model into a DDL script and generate a database based on the need.
Okay, more questions? No, okay. Thank you very much, and we close the first part of our section. It was the last presentation. Now we will have the lunchtime, and I am asking to join to our section at 2 p.m. For keynote presentation. So thank you very much and see you soon.
15 sekundžių.
Okay. Welcome back, everybody, to our conference, to our Intelligent Methods for Data Analysis and Computer-Aided Software Engineering special session. And I'm glad that that Professor Adel from United States, Kentucky is successfully connected to our session. Good morning, Professor. Yeah, because as I know, it is early morning now in USA.
It's 7 a.m. now, yes. I've been awake for a while to make sure I test the connection.
So sorry for inconvenience, because, you know, it's everything changes, the situation is difficult. So, okay, thank you very much. And we will have a presentation about the journey of artificial intelligence. So, Professor, the screen is yours. Yeah.
Okay, I'll share the screen in a second. Can you all see the screen now?
Yes, perfectly.
Okay. This will be just a little bit of a less formal. I don't know if you want to have people ask during the presentation or later. I am very flexible. And according to what I was told, the presentation is up to an hour. So is that correct?
Yes, yes.
Okay. Because I put my timer for 50 minutes so I can remember to slow down. Okay.
Okay, good.
Okay. I'll tell you a little bit about why I chose this title. I call it an AI journey because AI has been with us for a long time. And personally, I have been with AI also for a long time. So it is important that we remember that AI is not new. It's something that we have been with, and it's been with us for a very long time. So I just wanted to make sure the title reflects that. And personally, I am someone who looks at the future always with the understanding of the past. People joke about it with me a lot because I come originally from Egypt, and we have a long history, and the history tends to be something that I like. So I like to look at always the future with understanding what happened in the past. Otherwise, we don't get an informed direction. So let me move forward. This agenda is a loose, I don't have these titles exactly, but just to give you what I will be talking in general about, some background, some major challenges, some sample research projects to tell you, yes, I'm working on some things related to AI, where are we going, and some conclusions. So just the birth of AI. I mean, the concepts of AI are not completely new, but the word AI itself was only coined in a conference in 1956. Many of you, I'm sure, know this. And I'm just trying to get, yes, here. So many people know this, and there were a lot of senior people in that conference, which was at IBM. IBM, by the way, at that time held a lot of conferences, and I'll tell you about another story in a minute. But let's go about this conference, because the idea here was every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate. So it was about modeling and simulation of the learning and intelligence of the human. So AI really came out as an idea of how do we model the behavior of humans. And that brings my personal interest, because my personal interest started from modeling and simulation. And then my journey got me to meet with colleagues who were already starting in working on AI, and that's where I got interested. Ironically, at IBM, they had another conference, and my dissertation advisor was quoted to say something that many of you may laugh about, that digital computers are here to stay. At that time, analog computers were dominant. And actually, this presentation that he had given at IBM at a later conference, actually, in no earlier conference in 52, I think, or 54, people quoted it, that this was visionary, that even digital computers are going to stay. So AI, obviously, at that time was also visionary, and that really brings that companies like IBM had a history of innovation. They are working hard to maintain it, and that's something that we may disagree about. So McCarthy wanted to choose the word artificial intelligence, and some people were interested in cybernetics, and there were some famous cyberneticists that they wanted to avoid interfering with. So there were human political interesting challenges. So they didn't particularly get along with someone who was interested in cybernetics. They didn't want to use the same name. Lot of very interesting things in this history. So they came up with a more precise way, I would say, it is the engineering and science of creating intelligent machines that can perform every aspect of learning or any other feature of intelligence. So another aspect here, we go back to the Turing test, and the Turing test is still, people still talk about it. And the Turing test is based on the proposal by Turing, Alan Turing, that a game, an interrogator game. So can the interrogator tell if someone is in the room or a machine? And this game was published in the 50s. It's called an imitation game originally, and then it became widely known as the Turing test. The Turing test has challenges, because I remember there was a big hoopla one time in the Boston Museum of Computing, where they had a big competition to see which machine can be better. People can outsmart testing. I don't know if some of you, like me, are in education. If you prepare people for testing, all what they do is prepare for the test. So some people injected stupidity in their responses to make it look like human. So actually, if you game the test, you may look like a human and make it less intelligent. So that's one of these weird things about testing. You can read a lot of things about history. There is Stanford. There is a lot of very historical things about AI that I find fascinating. Here are some references. We can share them. But at the end, artificial intelligence, what's artificial about it is that it uses computers. So the idea there is, this is me, by the way, at the left bottom there, with what was a huge hybrid computer. Actually, this is only half of the computer. The other half is a mirror image of it. Then there was a small PDP-11 digital computer connected with it. And this was a huge modeling and simulation lab at the University of Wisconsin at the time, which I was there in the late 70s. And believe it or not, we used to model and simulate helicopters. We modeled economic systems. We modeled biomedical systems. And actually, one of the famous manufacturers of helicopters, Sikorsky, were very close to us. And they used to come and use this machine to test their new controllers before they launch them in the air. So a little bit here, you see, obviously, anyone will recognize this machine. This was the DEC machines, digital equipment. Then the PC started, But then people started to get jealous and they created, if some of you are know a little history of AI, this machine here in the middle is the Lisp machine. Lisp machines became very popular because they were very fast. By that time, by the way, I also managed to get Lisp on the PC. By the way, I had Lisp on the PC and Prolog on the PC. So this was really big for us. Lisp on the PC was a very interesting thing. You run the program, then all of a sudden it stops. If any one of you is familiar with Lisp, it does what is called garbage collection. So it starts doing garbage collection and the machine practically used to freeze. So computing was needed. And then obviously now we have NVIDIA, oh God, Tesla. I'm looking at the V100s these days and they are beautiful. And obviously on the cloud, AWS. And that's why, by the way, you see that my background is in the cloud since it's a cloud-based Zoom. So I decided, well, let me fly, okay? Okay, from a personal perspective, I tell you, I personally started getting interested in AI in the early 80s. And in the early 80s, there was actually a very interesting series of books, the Handbook of Artificial Intelligence, which was a 4-book series. And actually, some of my earlier work is referenced there, but that doesn't matter. The whole idea I wanted to share this is publications were starting to evolve, conferences were starting to evolve more regularly to the mainstream. And one of the books of one of my colleagues, Dr. Zurada, in neural networks, was one of the earliest neural networks book. Another colleague in my department, Dr. Kantardich, his first book on data mining appeared. And we see then a lot of interest, hundreds of books appearing, hundreds of publications. Things were just nascent at the time, lots of very good software development. Then you see a big boom. Watson was a big boom to AI when Watson beat the chess and then the Go game. And then you will realize everyone is in AI now. I cannot even, the field is so crowded. So I just to tell you, I was telling you what got me started, and I'll tell you some of my earlier works are really, when you look at them, they seem very naive nowadays, and that's why I wanted to tell you. Expert system for chemical process control, expert system for simulationists, rule-based layout planning for flexible manufacturing, multiple expert Delphi-based knowledge acquisition tool, expert system for matrix analysis, okay? I mean, the whole idea, then we had a huge group. Some of these people are very famous on teaching AI and expert system courses. And this was actually based on a workshop sponsored by the National Science Foundation. So even in 93, there was interest in the US about how do we teach AI and is it really taught in regular curriculum or not? So we understand that until 93, there was still this very relatively small group of people interested in promoting the teaching of AI. So I will just highlight some things that despite this naivete, a lot of the ideas are very interesting when I look back at them. Look at this multiple expert knowledge acquisition tool. This was an attempt to do what now is called fusion. So we had the same challenges and problems and dreams, but we didn't have yet the depth and the capabilities of the computing to let us do more serious work. But that tells you a little bit. And look at this, neural network for vision inspection. My student was Stomsky. He was of Polish heritage. And he used to joke because in the US, there was an old joke about how many Polish people it takes to do a light bulb, to remove a light bulb. And he was doing visual inspection of light bulbs, light filaments. And he used to just joke about that he happens to be Polish. And this at the time was a joke. So This work, we were doing it actually with GE data. They were manufacturing light bulbs. And to give you a hint of the challenges that were there at that time to train the neural network, it took about 20 hours on a digital equipment mainframe, but it took 2 minutes per light bulb. So it was not possible to deploy it. It was just a proof of concept. Okay. How did machines learn? Okay. And how do they learn still? Either we did them by algorithm, implementing an algorithm, and we are thinks because we are humans, we're smart, we can envision all the combination of our inputs and outputs. Well, that was naivete in some ways. Then I call some things knowledge-based systems that were either using numerical AI, like even Bayesian and statistical, or symbolic AI, such as LIST, and expert systems, which is like a combination of both, can use both of them. And this was a big deal. And I remember we developed at one time an expert system for hand surgeons to train people on hand surgery, because we were told doctors do not train on hand surgery, and we had some experts in this area. And this was in the 80s, and people were so thrilled about looking at it. Logic programming, some of you may know that Japan was the leader in logic programming, and they had a big initiative to push for AI using logic programming, and Prolog was at the time the big thing. And some of you may remember Lotfi Zadeh from Berkeley, and when he came up with fuzzy, his colleagues were making fun of him. I remember we invited him a few times, and Kalman, who's famous for Kalman filtering, and Kalman was his colleague, and Kalman used to write articles making fun of fuzzy, because fuzzy to them at the time sounded like something exotic. So yet fuzzy logic is still with us, and it's still a very good part of how machines learn. So I would go in a different direction, and supervised learning is by giving machines labeled data and information that we already know, or unsupervised learning, where we let the machines figure out type of relationships and let it kind of exhaust these patterns, find for us the patterns. We humans tend to recognize patterns very fast, particularly visual patterns. Some people can look at visual patterns and recognize them faster than others. I know some accountants will look at numbers and immediately figure out problems and errors in numbers. So humans are very good in patterns, and machines are probably good, but can scale more. And the whole idea, maybe I want to talk about why AI is important, is because of scalability. We are smart, but we are not scalable. So sometimes scalability becomes an issue. Then we'll talk about reinforcement learning, and these algorithms are like rewards. We know how we train kids, we know how we train pets, we know how, so we know now how to train machines by reinforcement learning, having the algorithms having reward or penalties as well. So I call this is data-centered AI, and this is an article I found in talking about the information age, data age by 2025, how many zettabytes there'll be. I'm not very interested in the exact numbers, but I want to tell you that this is the big drive for AI, is the expanded availability of data. And that's why I call it, now we're going towards what I call it data-centered AI, because of the era of big data. So in the past, we were focused on the simple examples that we could generate, but now there are so much data. Data can come, look at this, core, edge, endpoints is collected from sensors, from humans, from everywhere, from printed matter being transcribed into digital. So the sources of data is unlimited. And the ability to digitize data became very easy. Actually, Speaking of digitization, I've been a big fan of digitization. I tried to sell some company way in Lowell about digitizing their maintenance manuals for aeroplanes. And at the time, they were looking at them in microfilm, microfiche actually. So this at the time was revolutionary. They looked at me and it took them 5 or 7 years to make the switch. And they were so hesitant when I first talked to them. So digitization makes you able to search in the data, to utilize it. And that's the big trend now for what I would call data-centered AI or based on big data. Well, obviously, most of us know that deep learning is becoming a popular buzzword, and that's why some of my interests now are in deep learning. And actually, many of us in academia, if you don't use some word like deep learning or something, people will not get attracted to what you're writing. But so deep learning is it. So deep learning is a class of machine learning, obviously, which is a class of AI. So deep learning is AI, and AI is not necessarily deep learning. So it's a one-way path from AI into deep learning, but there are many other ways of doing artificial intelligence. Why deep learning and what is deep about deep learning? And I thought here I share this just simple because I'm sure many of you are already familiar with it. What it is happening here is, the feature extraction stage was a time-consuming stage that we humans had to do. And with the expanded of features, like it's not unusual now to have a huge number of features, and for a human to do the feature extraction became an overwhelming kind of task. So the bigger the data and the bigger the features, now we have what is called deep learning that can do for us all the feature extraction. And it's deep because it has more layers, as you probably are, some of us who work on this are aware. Interesting, I had collaborators that many years ago, we worked on CNN, convolutional neural networks, and published papers. But what I was doing at the time, and we were doing as a group, was very limited to small images and relatively small layers of the network. And because we had to do everything by hand and the machines were challenging. So I want to always emphasize that why I refer to some of the old work, not because of mine, there are many people who were working at these things at the time, is that many of the new ideas became possible because the old ideas were there, and because the computation is there and now available, computation and obviously storage. We cannot ignore storage as well, because computation without storage poses a challenge. Okay. Now I tell you something which may become more business-like. What are the challenges from my perspective in AI and deep learning and all these things? Data. And did I say that data is available? Yes. But data is available only to those who own it sometime, although there are more trends towards publicly available and shared data. Talent. So if you are a business, acquiring talent is not very easy. There is a competition for talent, and it's almost a war for talent between companies. And acceptability. Why do I say acceptability? Because to translate your work into a business and a product, you need the customers or the users at the end to accept what you do. So these three challenges, I look at them as like juggler. If you have all three of them in your hand, you're lucky. Otherwise, you are juggling them and you don't have all of them at the same time. And that's been a problem in the US at least. I'll talk about some of these challenges. availability of data, types of data, size of data, quality of data, distribution of data, silos, and disorganized data. So these are a lot of the challenges that we face with data. And let me tell you about availability of data. Legal aspects. You may have access to the data, but there are legal commitments and legal things that prevent you from using it. Then there are privacy protection considerations and effect of data set size in identifying individuals. So if the data set is relatively small in some categories, like for example, age versus age categories. If I put people over 95, there may be only a few individuals, and that becomes a legal liability that you are not protecting their privacy if you are looking at a particular organization. So sometimes even choosing the categories, whether they are male or female, based on the distribution of data, you might be liable that you are not protecting the owners of the data. So look at data in a very different detailed thing. It's not only, okay, I didn't put the names, but can people be reverse engineering and figure out the names? Actually, interesting, there was an article yesterday about a piece of data that was published in one of the newspapers that had a picture of someone, and wow, from that picture, boy, they figured out, they used forensics, they do the image processing, they figured out to trace it to a location, they figured out to trace it to a person who owns a computer store in that city, which was very interesting investigative reporting just from one piece of data that happened to be a story with a picture. So yeah, data can be challenging. You may be happy to use it, but it may come back and bite you. I published this paper a few years ago, and it became very popular. I don't know why, with a colleague who happens to be a lawyer. The danger of smart and connected communities, cybersecurity challenges in smart cities, safety, security, and privacy. And why I was envisioning this issue is because the more connected, the more we have cities that have public data about everything that happens, the security challenges are not the only problem, but there is also privacy and safety, because people may know more about you, and maybe not everyone is perfect. So some people may be evil. So take care. Types of data, we talked about data, but data comes in different flavors, can be numerical, continuous or discrete, categorical, text, formatted, unformatted, signals, audio, EEG, images, natural, graphics, medical. So data comes in so many flavors. So when we are working on something, we need to realize what types of data we have accesses. The more we can connect different types of data, the more powerful we are. And particularly, I work a lot in medical. Many medical data is in separated like different databases. The images are in a different place. The text from the doctor comments are written in a different place. The EEG is in some other place. So looking at that and bringing a team that understands how to work with all the different types of data is sometimes a big thing. Okay. Distribution of data. Okay. In many cases, should we normalize the data is another topic that people have to worry about, because sometimes normalization is good, sometimes it's not good. We're looking at data and is it balanced or unbalanced? For example, I'm looking at a particular hospital, and the type of patients that they have are a majority are okay, very small have very serious conditions. So if I want to predict those with the serious condition, they can in some cases look as if they are the outliers. And these are what we call the diamond in the rough. But these are the ones that they are interested in finding. So the data may not be balanced. So how do I do focus on finding these patients? So a lot of things, the type of data distribution comes into play. The size of data, I tell you, this is long ago. I've been worried about the size of data. How far is really the size very important? That's a very interesting concept because you see, this is a log scale, log 2 scale. The accuracy improves in a linear log, which means the training size, it takes a lot to improve the training size. So sometimes you may decide what is the threshold size of data so you don't have to keep collecting data and looking at what you're interested in. And then this is some other people working on the network depth, how much layers, 20 layers versus 56, and the number of iterations. And these are issues that I want to bring to your attention that they affect your effectiveness and efficiency in doing your work. Well, I mentioned talent, or sometimes the lack of. Why I call it sometimes the lack of? Because there is two competing parts in AI. There is art and there is science. We tend to be more biased towards science. Most of us, that's our training. But there is art. And in art, there is something I insist is practice. So practice is the art and appreciation of the beauty of the algorithm and appreciation of the approach is something that's very difficult to teach. So remember that algorithms are only the tools and data is fundamental to all our models, and talent is needed for successful machine learning. But also there is a third dimension, which I did not put here, is the business objectives. There is the art, the science, and then there is maybe a third arrow competing with it, which is understanding the business objectives. So we may have something elegant, something scientifically correct, but it does not meet the business project. So how do we bring this talent in one person? Well, I do not believe in creating superhumans, but I create in bringing humans together that can be super teams and super able to talk to each other and create this. And to me, this is the only way to bring the talent is to believe in teams and believe in the idea of exchange through different perspectives. Some people write about this in a different way, and the techno myths of deep learning, robust machine learning needs data and a lot more. And I told you about this a little earlier. And it's like there are a lot of technology myths, and I don't want to get into this. Another techno challenges, I have many years of historical data. Should I use all of it? How much historical data is required? How do I reduce or remove biases? Oh, biases is becoming a big thing in data because, didn't we say now is data-centered AI? And where did we get the data? From the past. So remember I said, if we want to predict the future, we need to understand the past. If the past was not good, so why should our models predict a good future? So this is very important, and particularly if the models are not predictive, but they are models to prescribe the actions of the future, they may bias the future as well based on the past. So that's a tricky thing. How frequently should I retrain the machine learning? And you know about retraining and the machine learning. What do we call this? Concept drift. And we may talk about concept drift a little bit later. How do I prevent overfitting? How do I ensure that the model is using appropriate features? Oh, features are very important. And that's why deep learning helps us in feature selection. How do I explain the model? And explaining the model is something that I will talk about a little later. I just use this very simplistic figure to explain data relevance. If the topology is that some concept fits clearly in this square or clearly is this part of a circular edge, the data that I collect and have to represent both concepts. And many times we don't understand the data and we don't know the concept because we collected the data. The data is what we have. And the problem topology is for us to find out. In many engineering problems and scientific problems, the problem topology is based on a theory or a concept that's well understood. But in many cases, we don't even know the topology. So how do we understand the data? Particularly, it's usually multidimensional. It's not like two-dimensional like that. This is obviously two-dimensional, X and Y, and the concept is the color, but it is usually many dimensions. So understanding the data, that the data is relevant to the topology, is it distributed evenly here, or there is more in the yellow or more in the green, that makes a difference. I call this the data diet. And the number of positive samples versus negative samples, like the number of yellow versus green, whatever you want to choose, which one you think is positive or negative, and affects the accuracy. At one time, also, the accuracy improvement stops. So there has to be some balanced representation. And this is a particular figure from a paper that we did long ago to show you the number of positive samples may affect the result. How deep is deep learning? Okay. This is published by, adopted from publication by Kohavi in '96, and I have the reference, and the training set and the testing set and the error rates. And based on different mining tools and approaches, you will look at the training set size and the error rate, and that tells you a little bit that at the end, many of them, the error rate is very close, but different models have different needs, okay? This is something interesting from an old paper, but I bring old papers because they are simpler. Many of the new publications don't give you the simple views. And this one I chose because look at that. This model, a number of layers, and we were looking at a concept here that has a square, and this square is not evident. And we plotted this in gray levels so we can even talk about threshold. So you see that there are here some suspicious, more lighter color things very far in the C, in the one in C, which means that model is not very good actually. It looks good on the top, but it is more confused here. And this model, the D, looks a little better in some sense. So then do you threshold at what level of gray level? So obviously the topic of here is, I call these gaps when you have an error far from the concept, like look at the C, these things, if I had the threshold make these white rather than black, then this model will have a gap in learning. It will learn the concept in a very strange way where it has something wrong in far from the concept. Yeah, this idea is very important because it's easy to visualize in 2 dimensions, but it's almost impossible in multi-dimensions, so you have to do it algorithmically. Then we have to talk about acceptability. If we are doing AI, and we want people to accept it, we have to be able to interpret our results in a way that's meaningful. We have to be able to explain them to our customers, and we have to make sure that they are fair, and we have to make sure that we do not abuse our knowledge, and that we develop some public trust. So to have our models and the AI acceptable, we have to worry about these things. interpreting your results, I just chose this to show you, okay, I can display things in different ways. This is, forget about the example, customers with purchases of greater than equivalent 400. I'm trying to predict this class. And revenue, do I interpret it like a curve like that, or I give it to the business people like the positive revenue? How much correct could I predict? And revenue that I would get, and the opportunity that I would lose because I made wrong predictions. So you see, I can interpret it in a way that to me, oh, that's a beautiful curve, or can simplify it to business ways. We are always very love this. I love explainability. I explain to people a lot, predicted correctly, predicted wrongly, how much is, you know, so this is another visual way to explain to them. It's a little more. Let's talk about biases. Amazon scraps secret AI recruiting tool that showed bias against women. So why did these tools come up and they showed bias? Because they were based on data that was biased. So if you create a tool based on knowledge that is historical, and that's what happened here. Employees in technical roles, how much men, how much female and males. And look at here in Amazon, apparently there are more females, but apparently they don't want to disclose how much of them are in the technical roles. So these are issues that becoming in the public nowadays. The goal is to automate us. Welcome to the age of surveillance capitalism. So there are people who are suspicious, and some suspicion has good reason, some doesn't. So we have to really create this trust. And these are articles that I find. How to build AI that we can trust. Computer systems need to understand time, space, and causality. Wow. This is one of my favorite words because I tend to call it spatio-temporal analysis, but you add causality, I don't know what to call it. You see? So actually, I have one student trying to look at causality with spatio-temporal as well, based on analysis of news articles and cyber attacks and other things. Does one trigger others, or are they related? And we're trying to see this type of causality. So this is very interesting thing, but can you trust it? I will talk about some research projects that I've been working relatively recently, and I will try to be a little brief in them because these are obviously things that are current and they are published and you can read them. Sentiment analysis from text, deep learning versus Markov chain based text generation for cross. So we were doing text generation for sentiment classification, and this is with deep learning, and this is partly transfer learning. So we have seed reviews, 10% labeled only, because one of the challenges of big data is not all the data is labeled. So you have a lot of data, but you don't have a lot of labeled data. So we have to sometimes do some seeding and cross-domain and these things, and I will not get into too much details here, but tissue classification, segmentation of pressure injuries. This is dear to my heart because I had family members that passed and they had pressure injuries, particularly if a person is in the bed a lot and they are diabetic. Oh God, pressure injuries become a big thing. And we've been working on pressure injuries a lot. Actually, we have a system that we are looking at deploying it already in a hospital in the next few weeks. And we can analyze the type of tissue, the granulation, and this. And let me explain to you why here AI becomes very interesting in the analysis. because what current practice is that the nurses and the doctors look at the wound and they put numbers, and next day or next week they come and put another number. But do they truly have these numbers in a subjective way? When the doctor changes or the nurse changes, can they relate to the last week and have an objective way of saying it improved or did not improve? So one of the benefits here is to track the progress of a patient. Okay, I think I'm getting closer here. So this is some of the architectures we tried. First architecture, second architecture. I will not get into details of this. I want hopefully to inspire you and get your question. This is another work related to colon polyps, because colon cancer is another issue that's very important. The different challenge here is that the images are more blurred and they are video, so you have to get it from the video. And this is work with collaborators in Spain. And about scalability, when you use multiple GPUs and things, so we can use deep learning and improve the scalability of the data by, and hopefully also improve the analysis and the results. So that's scalable healthcare assessment. This is one applied to diabetic patients. Trends on health in social media. Actually, this is interesting. We looked at what do people talk about on Twitter about healthcare. So we looked at different things and we see which states have more tweets and more interest, and in the frequency of tweets related to different topics. We applied it related to just different health topics. This is just an example to share. But we looked at even drug abuse related to opioid. So social media is a very good source of analysis, and AI can help us understand what's going on and the trending and these things we know, but how to utilize them to be beneficial. We also looked at multilingual tweets. So we looked at tweets in one work on 3 languages, in French, Arabic, and English for the same topics, to see if the sentiment and its change over time is different based on the socio-cultural influences. So, yeah, this is follow-up on topic analysis by state. And we'll find that different states are leaders in different topics. Digital health, more New York have more interest. Wisconsin is least interested. Ironically, I studied at the University of Wisconsin. Wisconsin has one of the largest electronic medical record companies in the world called Epic, but apparently the tweets did not reflect that interest. So, going there, where are we going? What's the future of AI like? Okay, we told you a lot of history. So let's look at a little bit of future. Obviously, too many options. It's a rich field. The computers are enriching it, and the knowledge is building where all of us now are experts in AI. So what do we do? New York Times says, fighting the coronavirus with innovative technology. Oh, so people are using AI and technology together, and years of experience building intelligent robots and things. Okay, this is another interesting article. AI and machine learning promises to revolutionize. Is expected to be AI in healthcare is 8 billion industry by 2022. So obviously there are fields that are niche fields that AI is going. I'm working on a proposal to our National Science Foundation. They are offering focus areas on smart and connected health, and they are going to sponsor some centers at the level of 4 million a year for up to 5 years per center, and they will sponsor many of them. So there is a lot of investment in research and in the future of how to translate all this knowledge in AI into fields that are struggling. Healthcare is one of them. Oh, but there are other applications. Look at this. Markets here. Automotive market is another big market. So automotive market is growing, and AI in automotive, I don't know if you are a fan of Tesla or not, but they are doing a lot of interesting work, and many other automotive manufacturers are getting into the same ideas of using AI in their things. So a lot of the challenge is how to translate the AI into the industries and how to translate it into the final product. Obviously, now we also think that quantum computing, this is particular work that we've been trying to do, tying quantum AI and healthcare. So this is by chance, one of my colleagues, we have a publication that got highlighted in the Swiss Quantum Hub in September recently about our attempt to use quantum computing for analysis related to dementia. Dementia is another challenging field in healthcare because it's not understood well. And with the increased aging population in the world, there is more dementia and more Alzheimer. And these are fields that are very challenging in healthcare. Well, high-risk applications. I don't know if any of you remember the Boeing accident, how confused AI may have thought pilots attempting to save the Boeing 737 that crashed. This is very actually brought to me a little bit of deep sorrow, because believe it or not, in the 80s, one of my colleagues who we started together working on AI ended up moving to Boeing, and I was approached to join him, and I didn't go, and he stayed for a few years. He stayed for a few years, but then he decided to go back to academia. Unfortunately, yes, deploying AI in high-risk applications is dangerous, and we all know that the Boeing 37 crashes, the last one was related to AI not being well trained. Google's medical AI was super accurate in a lab. Real life was a different story. So real life versus research. So this is another interesting thing is when you do things in the lab, they are controlled, but how do you deploy them? So this is really how the future challenges are. And these are the topics we want to talk about. These are the topics we want to get our research into. You know what? Some of you are like me, educators. You may have a student that does very good on the test that you give in the course, but when they graduate, they are not necessarily the best in real life on the job. And some may not be the best grades in the class, but they be the best in generalization when they get a job. So how do we create AI that can be easy to deploy and generalize the knowledge to the real world? That's a very, very, very challenging thing. And that's why this is very important. Can have a collateral damage. Deep learning is causing a climate change problem, according to some people. Why? Because it uses a lot of computation, which uses a lot of power, which produces a lot of heat, which consumes also a lot of unnecessary power. So should we aim at improving power consumption of our hardware, our AI, or should we work on improved algorithms for AI that don't necessarily consume a lot of CPU cycles and a lot of so here there is a philosophical argument. Should we focus about only the science, or would we include part of the science, how our science does not have collateral damage? future of AI. One of my colleagues, Dr. Roman Yampolsky, is very interested in AI safety and security and the super intelligence. And other people, Stuart Russell, who's very famous, has a book on human compatible AI and the problem of control. So these are people worried about the future. As AI, actually, I gave a talk on AI and cybersecurity. Are they adversaries or are they friends? If we use AI to be the attacker, there is a lot of challenges there for the defender. So these are issues we have to worry about. At the end, here I want to say that data quality and problem understanding are key to beneficial knowledge discovery. So we have to make sure we understand the problem and we have good data quality, and good meaning also unbiased. And we have to, this is my thing to remember. And this is sample of my collaborators. This is just a picture, happened to be last year, a year ago from July, because this July we couldn't get everyone together. And I think I stop here, and you can ask an expert. Probably that doesn't mean you can ask me, but I will be willing to answer questions.
Thank you, Professor, very much for a very interesting presentation. And I have, in general, kind of question. So, what is the biggest artificial intelligence challenge for the next decade, on your opinion, and what should prepare, who should prepare for, what skills to improve, what professionals and professions will be most needed?
Okay. I'd be obviously biased from the AI, computer science, and engineering perspective.
Yes, of course, of course.
Yes. But the most important challenges from my perspective is better explainability and better understanding of biased versus unbiased, and better generalizability, where you deploy something and the environment might let it face unexpected data or unexpected circumstances, and it creates a fail-safe situation rather than a disaster. So these are the three topics that I think are very important. Again, explainability, understanding of bias, and generalizability with a fail-safe situation.
Okay, thank you. I try to see, do we have more questions from our distance colleagues, remote colleagues? No? No, we do not have. Okay, so Professor, thank you very much. And could you please join the Zoom channel, which information I have provided earlier, for short briefing, short interview, and my colleague will ask you to answer several questions. And thank you very much. Thank you very much.
In person, I wish I was with the group in person. I was dreaming of visiting Lithuania. It seems like a beautiful country, and appreciate the opportunity of being with you.
Okay, thank you. And I am waiting for meeting you soon, maybe in next conference. Maybe the situation will be different, and I think that we will meet on site somewhere, maybe in Kaunas, because next conference we're planning to organize right here in Lithuania, in Kaunas, but you know, who knows, is it remote, is it on-site conference, but we're
the
trying
joke
to...
in the US is that after the election there will be no coronavirus.
Yeah, okay, and we should maybe implement kind of AI tools or methods, in order to predict this. Okay, Okay, thank you very much once more, and we're waiting you in Zoom channel. Thank you. Okay. Oh, it's perfectly on time. Okay, so welcome everybody to special session on intelligent methods for data analysis and computer-aided software engineering, the second part of this session. So the next presentation should be named Decision-Making Model at the Management of Hybrid Power Grid. So do we have a presenter? Hello, do you hear me? So we have Tatiana on site, online.
Good afternoon.
Good afternoon. Okay, Tatiana, so during this session, we will have 5 presentations, so please schedule the time. And because we agreed that each presentation should contain 15 minutes. Okay, so the screen is yours, Tatiana, we're listening.
Что? Сделайте здесь фотку, тогда просто фото твоего выступления. Не получилось ничего? One minute, please.
Okay, okay. So you should try to share your screen.
We are ready. We are ready.
Okay. Yes, we see the presentation. Thank you.
Yes. Let me present a report on the topic decision-making model at the management of hybrid power grid. Tatiana Levitska, Ukraine. This work is developed to developing a model of decision-making regarding the optimal control of the hybrid grid mode parameters, considering the forecast of the changes in the parameters of generation and electricity consumption in the microgrid. The decision-making problem at the management of hybrid power grids is formed in the condition of uncertainty and incompleteness of the input in information. In this research, the information support components arrays of alternative possible regimes have been formed based on expert evaluation. The decision selection criteria have been defined. Fuzzy production rules have been formulated, which consider the operational logic of the hybrid grid. The developed system of fuzzy production rules allows in the functioning process of the hybrid power consumption system to make changes in the mode of operation in order to increase energy saving, resource components of the power consumption system, and electricity quality. The decision-making problem at the management of hybrid power grids is formed in the condition of uncertainty and incompleteness of the input information, which makes it impossible to formalize it as the exact mathematical model. The problem with hybrid power systems is that they do not account for possible changes in power and power generation modes in the nearest future. This work, suppose, is to develop a model of decision-making regarding to the optimal control of the hybrid grid mode parameters, taking into account the forecast of changes in the parameters of generation and electricity consumption in the microgrid. This parameter is dedicated to the method of the choosing the possible exciting state of the hybrid power grid that allows to strike a balance between generation and consumption of electricity with sufficient the generated electricity quality. The issues of the choice of effective state based on the operational logic of the power grid operation will be considered. The effective decision-making methods based on fuzzy logic will be described, as well as the management decision issue using additional current information about an established mode and predictive information about electricity generation and consumption will be explored. The change hybrid power grid structure by switching changes will be carried out. From the possible exciting states of the hybrid power grid, one should be chosen that allows to strike a balance between generation and consumption of electricity with sufficient the generated electricity quality. The solution choice should also be based on the operational logic of the power grid operation. Therefore, in this case of effective decision-making should use of decision-making methods based on fuzzy logic. A microgrid is a system of subscribers. Each of them has owning renewable energy sources. Accordingly, the decision-making system for managing the microgrid modes should be multi-level. The lower level corresponds to the subscriber point level, which is the one considered in this research. An important feature of the subscriber point management system is that they are set up to maintain the current balance of consumption, electricity generation. Therefore, almost the only way to influence with the operation of the electrical modes control system of the subscriber point is to promptly change its structure due to switching changes. It is proposed to monitor the control process by monitoring the electricity quality, as well as the total capacity of its production from various renewable energy sources of different combinations method. Management decisions are suggested to be made using additional current information on the established mode, as well as predictive information obtained on the mathematical models basis. The subscriber point is connected to the hybrid microgrid by means of the B1 switch. Renewable energy sources are connected by means of switches B2, B5. Non-critical and balance load is connected by means of switches B6, B7. Critical load cannot be disconnected from the power grid. Renewable energy sources have connectors K1, K3, convert the DC voltage current of the source into AC voltage current of power grid. These processes are controlled by autonomous device controllers. Their task is to maintain either a constant voltage or the required load capacity of a subscriber point. Such regulation possibilities are limited because, as a rule, they don't consider the qualitative indicators of electricity, the integrated electricity consumption and power generation characteristics, the forecast environment characteristics, and the influence of the subscriber points. At the first type of decision-making criterion is proposed to accept the electricity quality indicator in a fuzzy form. You can see fuzzification of an indicator on this slide. The membership function to the term normal voltage is formed on the basis of the fuzzy quality norms given in. Formally defined membership functions are as follows on this slide. In this slide, you can see fuzzification of asymmetry coefficient. The term membership function are formed on the basis of the fuzzy quality standards given on slide 4. Only two of these quality indicators can be modified in the microgrid. As the second decision-making criterion type, it is proposed to select the electric capacity received by the subscriber point from the microgrid. This criterion is minimizing. It shows how much a subscriber point is able to function autonomously. Power sensor provide information on the current state of electricity generation and consumption. Firstly, it is the solar panel power. It is proposed to fuzzy the parameter PSB by introducing three terms: low, normal, and high. The term membership functions are as follows on the slide. The secondary, it is a wind turbine power. It is proposed to fuzzy the parameter PW by introducing three terms: low, normal, and high. The terms membership function are as follows on the slide. Output parameters. The output parameters of decision making are the control commands of the B1, B2, B7 switches. Switches B2, B3, B4 are always switched on when operating the mains. They turned off only in cases of dismantling, repair, or individual maintenance. Let the fuzzy value B1, membership function B1 value terms are as follows. When we have the current values term of fuzzy operational parameters and predictive parameters, it is possible to form a fuzzy inference system regarding the choice of hybrid power grid operation mode. The second rule means that when all fuzz or interface voltage have a normal or high level and the generation of electricity it is a normal or high level, then the subscriber point is able to provide autonomous power from alternative sources and can be disconnected from the microgrid. On this slide, you can see testing of the fuzzy production decision-making rules system was performed in the MATLAB Fuzzy Logic Toolbox software extension package. The term membership function of the output variable B1. You can see characteristic surfaces illustrating the operation on fuzzy logic output for the B1 switch. The decision-making problem in the management of the hybrid power grid is considered. The information support components for decision support the information support components for decision support in the management of the hybrid grid have been determined. Arrays of alternative possible regimes have been formed based on expert evaluation. The decision selection criteria have been defined. Fuzzy production rules have been formulated, which take into account the operational logic of the hybrid grid. Thus, the developed system of fuzzy production rules allows in the functioning process of the hybrid power system to make changes in the mode of operation in order to increase energy saving, resource components of the power consumption system, and electricity quality. The fuzzy rules system formed on the basis of expert judgment and mathematical models for predicting the level of the generation and consumption, takes into account the operational logic of the hybrid electricity network operation with a sufficient level of electricity quality and is part of the knowledge base. Thank you.
Thank you very much for presentation, and I have one question. Could you please comment your survey from practical point of view? So I mean that, do you plan, suggest, create, and put into the practice kind of decision support or situation modeling hybrid power consumption system related information system, software package, or tool?
We try to answer. We take a part of this work, and we have another participant who maybe who can answer on this question.
Okay, thank you. And in your opinion, who should be the main user of such kind of tool? For what kind of users this kind of system or tool is oriented.
Sorry.
Okay, no problem. So thank you very much. Thank you very much for your presentation. And now we'll have the next presentation named the mining data with many missing attribute values using global and saturated probabilistic approximations based on characteristic sets. Do we have the presenter?
Yes, we have. Hello.
Hello.
I join now because I have technical problems here with my computer. Everything is under control. I will present research of our team about the topic you said.
We can see you. We can hear you. Everything seems okay.
It's good. Now I will share the screen and share the presentation. It will be automatic, and then, as usual, I answer your questions.
Okay.
But give me 10 seconds.
Okay, great.
Stop video and share screen. Application.
My name is Patrick.
Sorry. And then I have okay, entire screen. Share. Do you see my screen?
Not yet. But it seems that it is on progress.
Okay, because I don't have an option to share application screen. I work at night about this.
We see the black screen right now.
Yes, I see also the black screen.
So it's good.
And then, wait a moment, I will try to stop and reshare.
Great. I see myself right now.
Yes. This is on this program, and Zoom doesn't do not catch my player. Wait a moment. I knew that it will be something wrong here.
Second zero.
Okay, if you can continue the conference, I will be next or next person. I will ask my friend to join from Rzeszów, and she have a Windows laptop with the Windows operating system, and there we tested at night, and from her laptop everything is under control. I have. Thanks. And I'm sorry.
Okay. I would like to ask next presenter. The next presentation named Analytical Model of Design Workflows Organization in the Automated Design of Complex Technical Products. So the presenter, are you ready?
Yes, I am.
Great. Okay, we can see your presentation.
Yeah.
You can start. Thank you.
Thank you. I am Nikolai Voit from Ulyanovsk State Technical University, Ulyanovsk, Russia. My topic is analytic model of design workflows organization in automated design of complex technical product. Automated systems are defined in GAST 44.601 as an organization and technical systems that provides solutions based on automation of informational process in a various fields of activity, management, design, products, and other, or the combination as well as in IEEE 3071 international standard as complex systems, intensively using software. In the business process management theory, theoretically computer science and design automation theory, the stage of creating such systems are presented by design workflows of design who intensively use software, computer, development tools. The processing of such workflows business process in the paradigm of end-to-end digital design contains key design procedure, analysis and synthesis, which are one of the newest area of research and significantly affect the result and success of design. At the same time, the problem of the success of design decision in this area has been dealt with more than 30 years. Such attention to the problem is caused by a high degree of development project solutions going beyond the planned time. Some citation folks is presented on this slide. You can read it. The problem of my topics, the relevance of research is determined by the fact that it's aimed at solve a fundamental problem of increasing the diagrammatic automated systems, workflows, models, processing efficiency in order to reduce the time spent on the development, increasing the diagrammatic models, workflows, processing success, fulfilling the requirements for resource constraints, including functionally financial component and deadlines, as well as improving the diagrammatic model's quality, semantic error control. This problem has a great practical importance. We can see design workflow organization analytic model. CM equals organization, orchestration, choreography, and ensemble, where a pair organization and orchestration defined internal organization design workflow. And this slide has different parameter variables as all names, be the set of all the names of organization. So a command itself is described by name and time. Command equals title, direction, and function. So variable reflect to value, for example, and other equations you can see on this slide. Next slide represents variables and expressions. Variable can have a limited set of values, 0 or 1. Phi, this is expressions which can have variables and means new. Choreography and orchestration, it can change a formally defined as follows system. Interaction, you can see in below on this slide. Next, design workflow organization analytical model must exchange between components. Assume actions during design workflow exchange as exchange and view as false is given as system. New workflow, state, title, direction, and time is very famous and very important parameters time in my work. A description of exams and operation semantics rules in this is model is presented. It has sending, receiving rules and assignment rules, sequence, parallelism, congruence, unconditional choice, conditional choice, structure congruent in mathematical formulas. I try to use this mathematical model on some organization and get values in put it into my analytical models. The result is presented on this slide. You can see assemble, design, and variability done. Initial values available in CM have the following values. You can see some values of parameters, variables, and component. They have any values, for example, 0, 1, or fuzzy values. I try to present analytical model with help a graph view, graph model. It has arrow and square, circle, where arrows are actions. For example, WC1, WC2, and others. It show action. This action must do engineer or expert and other people who decision making. So conclusion and future works in my works is presented in shortly. I say that is use it in real plant in Ulyanovsk. So we have an experiment and future works researchers are related to the interpretation of the grammatic models of design workflow. Acknowledgement: this research was founded by Russian Foundation for Basic Research and the government of the region of the Russian Federation. Grant number 1847 0032. Thank you for your attention.
Okay, thank you for your presentation. And I have a question in general, why you do not use the classical techniques and notations for business process models, modeling, for example, BPMN, or classical, for example, process mining, tools or techniques? What is the main idea and what is the main idea of this research? Could you please explain?
Okay, the main idea of my research is to modulate simulation of process. Other research as use BPML, UML, IDEF 1, IDEF 3, and others standards don't have mathematical parameters, and they don't let to control semantical errors, deadline, and others. For example, Wanderers use Petri nets. It's the very most approach to modulate simulation business process. But it has polynomial and exponential task difficult, very difficult. Other methods are very difficult to simulate business process.
Yeah, I understand, but you know, now we have new trend and new wave is process mining techniques, which is based on various Petri nets and or artificial intelligence methods, tools. So your topic and thematic is, your research area is very close to process mining techniques, yeah, for process mining trends and techniques. Okay.
Yes.
Thank you. Thank you very much.
Thank you very much.
Thank
you very much.
And the second presenter, are you ready?
Yes. Hi, I'm ready.
Just a moment. Okay, you are the your presentation is the fourth, yeah? Model-driven framework for optimum application placement in for computing using a machine learning-based approach. Yes. But the second presenter had the problems with kind of connection problems. Rafael? Rafael, are you ready? Okay, it seems that the second presenter not ready right now, so okay, please start your presentation. Number 4, named a model-driven. Sorry. Okay. We can see the second presenter, okay, but we don't hear you. We can see the slides, but we can't hear you. Voice problems. We can hear. Oh, the voice appeared.
Sorry, I try one again.
Okay, who is talking?
Teresa Mroczek.
Teresa. Okay, it's related with second presentation, great. Mes ką nors girdėsim ar ne? We can't hear you. Could you please repeat the screen sharing and check the voice option? Sound option on. Stop sharing now, and could you please try to reshare again?
I sent a link to our presentation.
Great. Okay.
Could you run?
Yeah, I'm trying to open it. Wow. So, I'm asked to log in using Google account. Could you please share the link which could be visible for everyone? Ne, tai jie gali pažiūrėti. Sakai, matysi? Aš tai nemanau, kad tu čia matysi. Nu tai jeigu jie tave ten invaitino, jeigu tave įtraukia. Next, Crystal.
Yes, I'm.
Okay, are you ready?
Yes, I'm available.
Okay,
I'm
we're
sharing
listening.
my screen.
We're listening. We can see your screen. Yeah, everything okay.
Hi, I am Madiha Arif, and I am a PhD student at National University of Sciences and Technology, NUST. Topic of my presentation is a model-driven framework for optimum application placement in fog computing environment using a machine learning-based approach. First of all, these are the contents I am going to share: introduction and background, literature review, research gap, proposed solution, case study, expected output, advantages of proposed solution, and conclusion and future work. First of all, as we all know a bit about cloud computing and fog computing, but I am going to share some of the background knowledge about it. With the advent of Internet of Things, massive amount of data is being generated from different sources. The centralized architecture of cloud has become a very inefficient form of from the services point of view, like it has become difficult to provide a good response time. It has low responsiveness, high latency, and low throughput services. This all has become possible due to the centralized architecture of cloud computing, so that all the services are not fully being provided to satisfy the quality of experience or expectation of the IoT-enabled cloud computing applications. So the device solution suggested for problems related to cloud computing was to introduce some distributed system that can handle the resources allocation more appropriately. So the concept is named as fog computing. The main aim of fog computing architecture is to fully utilize the benefits of distributed computing and address the problems that were really caused in the cloud computing. So Cisco introduced the idea of fog computing in 2012, and a lot of work from now till from then till now have been done to enhance the availability of services from fog computing to the IoT-enabled applications. However, there are some issues related to resource management and fog nodes allocation to the requesting application based on user expectations in the fog layer that need to be addressed. So this is the literature review. The literature review is summed up here about there are some of the techniques. These are mainly I have selected machine learning techniques because I have proposed my model in this aspect. Historic based, heuristic based, or fuzzy logic, genetic algorithms. There are various algorithms used, and the different parameters have been addressed. Then different simulation tools are used to verify the results. And I have also highlighted some advantages and weaknesses of the already proposed methods. Now, moving towards this identified research gap. So the gap I have identified is that there is a need to create less complex yet optimized IoT-enabled application placement framework based on maximum degree of users' expectation satisfaction by the assigned fog node. The two main aspects here we have highlighted are the optimized service delivery to the IoT-enabled application and to satisfy the maximum degree of user expectations. So the proposed solution is a model-driven software engineering-based quality of experience-aware application placement policy comprising of several rule-based machine learning approaches. We have highlighted here that all the approaches of machine learning are here rule-based that prioritizes different application placement requests and classify the fog in computation instances based on the user expectations and current status of instances. So here is the meta model of our proposed solution. It is a model-driven software engineering-based model. Actually, the MDSE or a model-driven software engineering is meant to develop software by exploiting the problem at domain model level. So this is the domain model of our proposed framework. This will further go to the implementation phases. It is the abstract representation of the knowledge that we have, that we want to share. There are two main sub-modules. One is the fog layer and the other is machine learning layer. Fog module is composed of fog computational nodes and fog gateway nodes. Fog computational node is further divided into communication, controller, and computational component. Fog layer can have multiple fog computational nodes, and each IoT device can be connected to a limited number of nodes. Like these computation nodes are the ones that compute and provide the services to the connected devices, while fog gateway nodes are meant to attach those devices to the fog computational nodes. Fog gateway are below the layer, then above the layer are multiple fog computational nodes. Then communication components perform networking tasks like packet forwarding, routing, etc. All these are basics of fog computing architecture. Then controller component is there to monitor and control the functions of communication and computational components. Then fog gateway node contains application display unit, and data container display unit contains the name of the requesting application, the device which is requesting, and the IP address of that device. Then there are some MCI. MCI index is basically the microcomputing instances where application executions are assigned, and these calculations will be further used for prioritizing the fog computation node for the requesting application. Then the next submodule is machine learning layer. This has been introduced in our model. This is the most important layer where the actual placement logic is performed. It is a machine learning layer. This layer provides a machine learning algorithm selector. This selector is a rule-based algorithm selector. That rule-based algorithms can be selected through it among 4 of the provided algorithms: Bayesian tree, 1R, fuzzy logic, and Ripper algorithm. We all have been familiar with basic knowledge of these, but I'll explain a little bit that all these algorithms generate some kind of rules based upon some parameters. The parameters will be the expectations of the user that will be fed to the system through the requesting application. Then these parameters like access rate, required resources, processing time, round trip time, resource availability, processing speed, service delivery deadline, and all these parameters will then be fed to the along with their values will be fed to the machine learning layer, and where the rules will be generated, and based upon those rules, the next incoming requests of the applications will be handled, and then the fog computation nodes will be allocated based on that. How the application placement will work. First of all, there is an application initiation. In initiation unit, it initiates the client's application through the fog gateway node in the fog layer. It allows users to convey their expectations in the form of parameters. The capacity index from microcomputing instances are stored in the data containers. You can see that. Then there is placement module. Placement module is the main idea of the research, that placement module performs the actual application placement based on the optimum satisfaction of the user expectations related to the quality of the service they want. Then machine learning module is basically a generic model that we have tried to provide a generic approach so that it can be modified later on with different expectation parameters and with the type of the rules the user wants to generate. And the main reason behind using rule-based methods is that the variety of inputs that can vary from user to user and can be enhanced or reduced as per the user requirements. So the user expectation matrix can include all the normalized parameters. Here we have shown that parameters are normalized and then fed to the fuzzification and defuzzification processes. This is all in the fuzzy logic. I'll explain later. Then application is, then there is a placement module that maps the generated rules based on the expectations. Actually, the objective function in the mapping module then optimizes the rating value, and the application is placed in the respective node in the fog layer. And here the objective functions are also generalized. They can vary according to the user's preference and can be customized as well. So an objective function can be changed or can be added by the user, and then can be used based upon the preference it wants or weightage it wants to provide to any of the parameters. Then, so I have explained my model. Next is the case study, a little case study that we have conducted. The proposed model is applied on a real-time scenario. Consider an application that is an IoT enabled and installed on a user device. And this application sends signal to the fog layer through the fog gateway node. The fog gateway node initiates the application and then displays it on the user's IoT device. Then it collects expectation metrics from the IoT app provided by the user and save it in the data container. Then in this, this is actually the instance of that model. So for the instance, we have used fuzzy logic. This is our rule-based algorithm we have selected so far. Fuzzy logic is applied here for two reasons. Firstly, such systems get stable results quickly. very quickly. And secondly, it is scalable as well. Users' expectation parameters are normalized first and then converted to fuzzy dimensions using membership function. Hence, a membership degree of each expectation parameter is obtained through this function. Set of fuzzy rules are then generated using the rules membership degree of fuzzy output. The output is generated, and for each output, there is a singleton value calculated. This is then set for the mapping purpose. At the end, optimization is performed. The produced singleton value is then used by the optimizer to place the application in a fog computing node. The optimizer will solve the optimization problem, and application placement will be done based on some objective function we have shown here. The fog computation node is selected based upon the required expectations and the matching capability of the fog computation node. So this is how the things are going to work. The expected output of this model, as this is the most abstract form, most generalized form of the framework, the model will further be generating a Python code with various modules of the model as functions, as Python is well known for machine learning algorithms. And so this is a model to code generation problem, and many built-in packages are also available for Python. So machine learning applications are well designed to be, Python is well designed to be used in machine learning. Okay, the advantages of our proposed framework include it has reduced the complexity of the placement system by providing the lower level implementation baseline in an abstract, in a very abstract format, in the high level format. The model is reusable and can be modified as required with more user expectation. As I have already told, expectation metrics can be changed and can be varied based upon the application, as there are some applications that need good throughput that otherwise, and there are some who need a good response time. It depends upon the type of the application. There are some are real time, some are not. So they can be, expectation parameters can be different. The optimum placement of application can be achieved through this model because they get the best fitting for computational node for the expectation values. The model is flexible and can be enhanced for additional machine learning algorithms. Algorithms can further be added in the selector module. The module can generate an organized code. It will be a well-organized Python code. And each module will act as a function, and this subparts will be as sub-functions. This model can be used as a source model for model-to-model or model-to-text transformation as well. So this is the conclusion that we have proposed a model-driven based framework for placement of IoT applications on fog nodes in fog computing environment, use of machine learning approach, and the framework has provided a flexibility for adding more expectations. And this model is a very generic solution for the problem of application placement in fog environment, which is flexible to be enhanced and transformed into a well-formed code. Thank you so much.
Okay. Okay, thank you very much. And I have one question. In your conclusions, you stated that this model can be further simulated and can be used for real-time scenarios. Yeah, and could you please give an example of one of the real-time scenarios?
For the real-time scenarios, I mean that there are applications, real-time applications that are IoT enabled and that use cloud computing, and further for computational nodes will be used. So for any kind of application, like it can be any application, real-time application that is capturing some environment, like an environmental data like moisture and different kind of parameters, and then it needs a very fast response time. So for this kind of simulation, this model can be easily used because data is very much changing with time, with every minute, and that application is gathering the data and wants it to get processed very quickly. So for computational node will then be a very good way of saving that large amount of data and processing that at the same time. So this is what I mean by
Okay.
real time.
Okay, thank you. And we do not have more questions, or we have? No. Okay, and I can see the questions from distance. Okay, thank you. And now the presenter should present the last presentation, diffusion of knowledge in the supply chain over 30 years, thematic areas and sources of publications. Are you ready?
Yes, I'm ready.
Great.
We are ready.
Okay, you can start.
1 second. So you could hear me, yes?
Yes, we can see you. We can see your presentation. We hear you. Everything fine.
Thank you so much. Good afternoon, ladies and gentlemen. My name is Julia Bulhakova. My co-authors, Professor Anna Mariniak, Magister Monika Bal. We are from Poznań University of Economics and Business. We will try to present the results of our work, diffusion of knowledge in the supply chain over 30 years, thematic areas and sources of publication. The research aim had identified the dominant theoretical and empirical thematic areas in the field of supply chains, which have been undertaken in the last 30 years. The development of the supply chain concept can be divided into 3 phases, which are logistic management phase, value chain phase, and supply chain network phase. On alternative, similar model distinguishes the phases of fragmentation, consolidation, integration, value capture, and automation. In our research, we have traced the development of the supply chain based on the diffusion of topics that have been the focus of scientific interest in the last decades. Based on the research, it was possible to identify the carriers of knowledge in supply chain management. These carriers are countries, authors, and publishers, which were the most productive in the field of supply chain management. Additionally, it was possible to determine the most active entity in the supply chain management sciences. In the next stage of the study, all keywords were separated according to Scopus nomenclature. And next, the words that were cited 100 or more times were analyzed and grouped thematically for each time series. The scientific center from which most of the supply chain publications come from currently are largely located in countries such as Germany, India and the United Kingdom, the United States and China, with growing interest in supply chain issues and Asian countries in the study time period. Based on the analysis of source data, it can be concluded that the popularity of some topics has increased particularly dynamically over the last decade. These are sustainability, life cycle, commerce, competition, human, coordination, risk analysis, sales, and ecology. There is also a group of topics that is consistently at a high level of interest among researchers. It's connect with such keywords as cost analysis, information management, inventory, competition, and product design. Due to the extensive list of generated data, figure presents a ranking of the most popular topics over the period under study. Now I want to ask Monika Bal to continue our presentation. 1 second, I want to make new sharing.
Still with your screen.
Yes, it's like new sharing. It will be possible or not? I don't know why I couldn't see this sharing. So maybe I will click. Okay.
Yeah, no problem. So I will try to briefly comment our last step of research. From that chart, you can see number one in terms of popularity in keywords in each time period. In the first 2 times period analyzed, researchers focused on inventory or stock. Next 15 years were about cost analysis. And the last analysis time frame, 2015-2019, researchers focused on sustainable aspects of supply chain. And from the analyzed keywords from the last 2 years, from 2019 and 2020, we can assume that the next decade, 2020-2024, the focus will be on Industry 4.0 related topics, of course, in area of supply chain. For example, blockchain application in supply chain, Internet of Things, big data, and maybe more in inventory management. There will be 3D printing, autonomous vehicles, autonomous robots. What else you can see from that picture is that general number of articles on the subject of supply chain is growing with time, just with a few exceptions. Every year you can see there is more research. We can conclude that that main topics like inventory, cost, sustainability, Industry 4.0 are growing. Importance of the subjects is growing in time. Okay, next. Now I will try very briefly summarize our research on particular data. From the first 2 time periods, main subject was in inventory. It was in 1990, so 30 years ago. And in that time, researchers focused just on basic stock management strategies. And then they analyzed that the knowledge of these strategies is key for success of management. Later, they were also analyzing optimizing stock levels, different ways of that optimizing. And they found out that decentralizing control of goods flows in supply chain can lead to bigger profitability. In the next time period, next 5 years, especially popular was the term of bullwhip effect, which is growing flow level distortions, growing down in a supply chain. And it started to be more popular subject of sharing information, which is leading to lowering inventory and finally resulting in lower costs. And researchers also started to talk about different EDI type tools, so in electronic data interchange. That subject was later also very popular, but the popularity started in this time period. Next 15 years, in years 2000-2014, main analyzed subject in supply chain was cost analysis. And mostly, of course, researchers were interested in lowering that costs. Especially popular subject in years 2000-2004 was a vendor managed inventory, which is inventory managed by a supplier, not by that own company, which was quite a new idea in that time period. There was also a dilemma of using EDI as a main system in supply chain or versus online platform. EDI is a more effective tool. On the other hand, online platform is possible to implement for every even small company. That means it's not excluding some small suppliers from a system. And the last area of interest of researchers we found out in that time period was KPIs of supply chain, and most popular KPI was cost. That's quite interesting because researchers decided that much more important is value, but analysis of business proved that business is still focused on cost. Next time period, researchers were analyzing a criterion of choosing suppliers and analyzing different tools for that. There were also some articles about transactional costs, so some economic theory implemented in supply chain, not in one business. That was quite a new idea at the time. And in that time started interest in greening supply chain, which will continue later in time. Scientists proved that greening tools really leads to some economic value for a company. In the third time period when cost analysis was leading, mostly scientists were talking about integration of supply chain while greening that supply chain. Okay, next. And the last analyzed time period, 2015-2019, was all about sustainable aspects in supply chain. The results of research from that time were sometimes quite surprising. For example, that analysis of risks in green supply chain proved that instead of big media coverage of some social risk, that business actually is not really taking too much care about social risk, and much bigger risk for a business is economy, connected with economy and ecology, two other aspects of sustainability. There is also quite interesting research about a positive and environmental impact of economic crisis. Of course, that there was analyzed that all 2008-2009 economic crisis, but I think this possibly interesting research in future, if currently is also resulting in greening supply chain and in positive results for ecology due to crisis. About green technology, scientists were continuing their analyzing economic value of greening technology. And the last analyzed by us term was choosing green suppliers, especially choosing a tool which can help choose good green suppliers. There were tools like Vitor or ICIST tool. Okay, summarizing that research, our proposals for future research is there is a need for more research connecting the three most popular subjects: inventory, cost analysis, and sustainability. The creation of sustainable chains should aim to optimize the stock management, as there is a huge potential for savings in the efficient stock management, reduction of gas emissions, and the reduction of waste. Therefore, there is a need for evidence of our hypothesis 1, the implementation of the idea of a sustainable supply chain has a positive impact on stock management in social, environmental, and economic terms. There is also a need to explore the links between the implementation of sustainable activities in the chain and business costs. Studies to date indicate reductions in energy consumption, waste, etc., but there is a little concrete calculation of the savings generated. It's therefore provisionally assumed, our hypothesis 2, the implementation of sustainable chains has a positive and measurable impact on the financial sphere of the whole supply chain. And now some final points about future research will tell Professor Anna Maria.
The literature review shows that the potential of 4.0 technology in supply chain is still underutilized. Most articles highlight their positive impact on supply chain management. In the analyzed article, simulations of case studies or traditional case studies were used as a research method. Quantitative research is only at the initial stage of development and usually concerns one selected technology. In the context of supply chains, digitalization, one of the most popular topics today, is 3D printing. And this technology can be used in many sectors, such as aerospace. Empirical research indicates many advantages of 3D printing, such as the simplification of supply chains by omitting production stages of individual parts and the possibility to decentralize the production. This shortens the delivery time of products which are manufactured closer to the consumer. Another technology discussed in the study is the so-called augmented reality. Among other things, it is used in designing parts, production simulation and visualization of these processes, virtualization of products, and shortening the time and cost of developing the project. Another of the analyzed technologies are autonomous robots. Using specific examples, the authors prove that robots are particularly helpful in situations of fast-changing product line with complex and labor-intensive tasks and high startup cost. As for the next technology groups, autonomous vehicles, the literature highlights that by using wireless car networks, intelligent transport systems have the potential to shape the future of multimodal logistics. Among other things, it is indicated that unmanned vehicles can be useful in humanitarian actions, reduce energy consumption, and can help with the inventory process. The last of the analyzed groups is the technology of system locating moving objects in real time. Technologies of this type, among other things, increase the transparency of supply chains and therefore allow for the creation of sustainable supply chains. Next, please. Supply chain 4.0 positively influence creation of sustainable supply chains in the economic, environmental, and social dimension. Thank you for attention.
Okay, thank you very much for your presentation. And I have one question. So if I understood correctly, you have analyzed the evolution of the supply chain over the past 30 years. Yeah? And could you please name the evolution of supply chain trend for next decade or 3 decades?
Thank you for your question. Very interesting question. Yes, of course, we made this analysis, and as could you see, it will be about supply chain 4.0, about digitalization of your supply chain, about using new technology, and yes, we suppose it will be a trend for next years.
Yeah, I will maybe tell in particular which technologies will be in interest. I told before just main, but maybe I will tell now full list. So it's Internet of Things, big data, cloud computing, blockchain, CPS, cyber security, M2M, layered production of products, which is additive manufacturing and 3D printing, augmented reality, autonomous robots, autonomous vehicles, technology of systems locating moving objects in real life. That's areas which we think will be special interest.
Okay, thank you very much. Thank you.
I think in the future there's a need to establish a list of factors that determine whether the implementation of digitalized change be in fact postponed, completely abandoned, or prioritized.
Okay, clear. Thank you. Thank you for answers. Thank you for presentation. And now the final presentation should be number 2. Are you ready, colleagues? Teresa, are you ready?
Hello, can you hear me?
Yes, yes, we can hear you.
Our colleague, Patrick Clark, prepared a video presentation, and I trying one again send you a link.
Okay.
Because he's in another time zone.
Oh.
And
okay, great.
Present our results on the topic of mining data with many missing attribute values using global and saturated probabilistic approximations based on characteristic sets.
No.
We consider data sets with 2 types of missing attribute values. Lost values and do
Gerai, share spaus. Full screen.
Using global and saturated probabilistic approximations based on characteristic sets. We consider data sets with 2 types of missing attribute values: lost values and do not care conditions. Lost values, denoted by question mark, are interpreted as values that were erased or not inserted. Do not care conditions, denoted by star, have another interpretation. We assume that the original value is irrelevant. In our research, we used 4 approaches to data mining, combining 2 types of missing attribute values and 2 types of probabilistic approximations, global and saturated, based on characteristic sets. Our main objective is to find which approach provides the most accurate rule set as measured by the 10-fold cross-validated error rate. In order to explain our approach to mining incomplete data sets, we use a simple, incomplete decision table. In the decision table, the independent variables are called attributes. Temperature, wind, and humidity are all attributes, whereas the dependent variable, trip, is called a decision. For complete data sets, the block of the attribute value pair is a set of all cases for which the attribute A has the value V. For incomplete data sets, if for an attribute there exists a case such that the corresponding value is lost, then this case should not be included in any block of the attribute value pair. On the other hand, for do not care conditions, Such cases should be included in all blocks of the attribute value pair of all specified values of the attribute. For example, all specified values of the attribute wind are low, medium, and high. The wind low pair appears for case 3. The wind medium pair appears for case 1, and the wind high pair appears for cases 5 and 6. However, for cases 4 and 8, for the attribute wind, we have the do not care condition. So these cases should be included in all 3 blocks of the attribute value pairs, wind low, wind medium, and wind high. For cases 2 and 7, the attribute value of wind is lost. Therefore, cases 2 and 7 are not included in any block. For a given subset B of attributes, the characteristic set is the intersection of the sets of cases corresponding to a given block of attribute value pair if the value of the attribute is specified, and the universe if the value of the attribute is lost or do not care condition. Let's return to the decision table and consider the third case. In this case, the attribute temperature has a value of do not care condition. The attribute wind has a value of low, and the attribute humidity has a value of medium. For this case, the characteristic set is the intersection of the following sets: the universe, wind low, and humidity medium. Assuming that B is the set of all attributes, all the attribute value sets and characteristic sets are presented in this slide. Incomplete decision tables are described by the characteristic relation in the same way as complete decision tables, by the indiscernibility relation. This binary relation on the universe is known if we know characteristic sets for all cases belonging to the universe. Global probabilistic approximations are constructed from characteristic sets and are associated with an additional parameter threshold, alpha. Our research is focused on heuristic versions of global probabilistic approximations. They are named MLIM2, Global Probabilistic Approximation, and the Saturated Probabilistic Approximation. MLIM2 Global Probabilistic Approximation is a union of characteristic sets most relevant to the concept. Another way to explain the idea, the intersection of the concept with given characteristic sets should be as large as possible, and the conditional probability of the concept given the characteristic set should be greater or equal to alpha. If more than one characteristic set satisfies both conditions, the characteristic set with the largest conditional probability will be selected. If this criterion ends up with a tie, the characteristic set is picked heuristically from the first on the list. On this slide, we present all distinct MLIM2 global probabilistic approximations for the concept yes and no. Of the decision trip, the distinct approximations were obtained for the parameter alpha equal to 1, 0.75, and 0.5. Saturated probabilistic approximations are also unions of characteristic sets, while giving higher priority to the characteristic sets with larger conditional probabilities. Additionally, if the approximation covers all cases from the concept, the algorithm will stop adding characteristic sets. Similarly, as before, on this slide, we present all distinct saturated probabilistic approximations for the concept yes and no of the decision trip. The approximations were obtained for the parameter alpha equal to 1 and 0.75. Our objective was to find the best method among 4 methods of computing approximations and inducing rules. 6 datasets from the University of California Machine Learning Repository were used for our experiments. For every data set, a template was created. This template was formed by replacing randomly a maximum number of specified attributes with lost values. The maximum missing was different for each data set, but is defined as the largest number of attributes replaced where all cases have at least one specified value. The same template was used for constructing data sets for do not care conditions by replacing question marks with stars. We used the MLEM2 algorithm for rule induction. The parameter alpha was equal to 0.5 for the two option types of probabilistic approximations, global and saturated. However, the parameter beta varied from a value very close to 0 to 1. All experiments were conducted against two interpretations of missing attribute values, lost values, and do not care conditions. The results were compared for statistical significance using the Friedman rank sum test with the post hoc multiple comparisons at a 5% level of significance. For breast cancer, the maximum number of missing attribute values was 45%. The experimental results show that global do not care conditions and saturated do not care conditions perform better than the same lost value interpretations. Also, the global do not care condition is better than saturated do not care conditions. For echocardiogram, the maximum number of missing attribute values was 40%. Global do not care condition is more accurate than saturated do not care conditions, which is better than global and saturated lost values. For hepatitis, the maximum number of missing attribute values was 60%. Global lost values, saturated do not care conditions, and saturated lost values are all better than global do not care conditions. For image segmentation, the maximum number of missing attribute values is 50%. Saturated do not care conditions is better than global do not care conditions, both of which perform better than global and saturated lost values. For lymphography, the maximum number of missing attribute values is 55%. Global do not care conditions, saturated and global lost values all perform better than saturated do not care conditions. For wine recognition, the maximum number of missing attribute values is 65%. Global do not care condition perform better than global and saturated lost values, all of which perform better than saturated do not care conditions. In this paper, we compared 4 ways of rule induction, applying 2 types of missing attribute values and 2 types of probabilistic approximations. As follows from our experimental results, there were statistically significant differences between the 4 methods. However, the best way, as measured by error rate, will depend on the data set. As a result, the best selection for rule induction should be selected by running experiments, taking into account all 4 methods. Thank you for your time today.
So, okay, finally we had the presentation. So we have one question from Professor Evaldas Vaičiukynas.
Hey, hello. Is there somebody?
Hello?
Is there somebody who can answer?
Yes, I am here, but I don't. Do you hear me? The first question. Do you hear me?
Yes, we hear you.
Oh, okay. The situation is under control, so I will disable video and I will ask your question.
Mm-hmm. So my question is, you showed your method, which seems to work, at least in the slides, it was working on the categorical attributes. How do you deal with integers? Because some data sets you used have not only categorical. So did you just skip the integers or what? And then
No. We have the procedure to process the integers, and now we show only. This is the default mode of the operation of our software. That if I will introduce the numerical attributes to the program, the program will in an automatic way discover the numerical attributes, and it will translate it for the categorical values. We use two approaches for this this topic.
So you
Now,
basically what you
have
do.
a broad, we conduct a broad research in this area. So now is a narrow topic connected with only how to choose elements to build the concept. And your question was about these attributes, and we have the procedures. I can present the procedures if you want, but this is a broad topic, too broad for 2 or 3 minutes.
It's called.
We make some kind of overlapping. I don't have a word. Overlapping areas of the attributes, and using these overlapping areas, we build numerical symbolic values. It's a very general view of these techniques, but we have the procedures to proceed, of course, numerical values.
So basically, it's discretization, if I got right.
Sorry, I don't hear you.
You discretize integer to categorical. Is that correct? You discretize. You make it categorical by using intervals.
I only add that the experiment was on numerical data conducted, but for presentation we use categorical attributes.
So you extract rules for integer data. How do these rules look then? Because you showed some rule induction, right?
Yes. I get the question now. The rule about the integers. You have I must find the word because I must find the word. Wait a moment, translator. I'm sorry. Przedział in Polish. And,
wszystko w porządku.
Yes. Yeah, interval. Okay, I'm sorry. We use intervals, and in rule there is a presented interval. So, for example, a temperature is about 10 to 20 degrees. So this is an interval 10.20 degrees, and this represents all the broad spectrum of temperatures encoded in it. The internal representation of our method are symbolic once we are in the field of artificial intelligence, but we also plan to integrate with the numeric intelligence because of the topic of symbol grounding, for example. This techniques for building the concepts can be applied there to propose a process of higher level knowledge information transformation to the knowledge.
Okay,
thank you
very much. Thank you. So, thank you for participants of this special session on intelligent methods for data analysis and computer-aided software engineering. And thank you for participating. Thank you for articles. Thank you for discussions. Thank you for participants, for on-site participants as well as for remote participants. And I would like to ask you to send the articles to the next year conference, which we very hope that will be organized here in Kaunas in Lithuania on site. and we hope to see you here in Kaunas, and thank you for participating, and I very hope that I will see you next year here on site in Kaunas. Tomorrow. Yeah, and see you tomorrow in next sessions. So thank you very much once more for participating. Thank you. Bye.